Alright, so let me move some things over for a second here. This shouldn't be too long because I'm kind of tired, but I wanted to at least get a little bit more work done. So we're going to make a way to back up the different pixel data allocations that are going to be used for the GPU. We want to find a way to back those up because it seems like a common pattern where when we want to test out certain systems and poke and prod at their data, we kind of like want to back it up, and then we want to mess with it, and then we want to restore it. So at first I was thinking that for these systems here that we've been writing a lot of code for, these texture as uniform systems, that we would just create a, like, between systems 19 and 20, we would create a new system that is specifically meant to back up data for these systems. But these systems just use data from pixname, so what we really need is like a pixel name backup system. And the idea is to make sure that, we want to adhere to the idea of do one thing and do one thing well. So if we come back to something much later, we don't want to just stick more code on it, right? If we're coming back to something much later, there's a chance that that means it's a different problem. It's not it should be in its own category. Hold on. No, not over here. Hold on. Some of these windows don't quite snap to the size I think they should snap to. Okay, there we go, I think. No, it's still like, oh, it's OBS that is leaking over the side. Hold on. So OBS does not like my, I have my toolbars on the top of my monitor, and OBS doesn't like that very much when I try to snap the windows to where they need to be. Okay, I guess that's working now. Everything still seems kind of... Wait, over here, this guy. Okay, is everything snapped in place? Okay, yeah, okay, we're good. So we want to make an insertion, I think, right here. And if we want to take a look at pixname, right? Pixname is just a whole bunch of data. And this is the data that I'm really concerned about when I'm talking about backing it up. Now, we could kind of like just put this stuff into like pixel name functions, right? We could like throw it in and say, well, it's pixname stuff, so why not just put it in the pixel name functions, right? So if we look at pixname and we look at the functions, I mean, there's not much there anyways, right? But the thing is like I said, if we're gonna, we made this quite a long time ago, and I think that if we make something that long ago, it seems to me like it's another category. I don't want to. What I want to do is I want to avoid, like, I know I don't want to be too granular. I don't want to be too granular. I want to keep things coarse, but at the same time, I want to avoid like the potential God objects, right? Where you just like, oh, hey, well, it's right here. The path of least resistance is just to throw stuff right here, right? Throw some backup functions in here and whatnot. But I think that's the wrong idea. So I think we'll just call it Pixback, and it will be basically a function-only system, right? And so if it's a function-only system, it doesn't have any data that goes with it because it uses pixname's data. And, maybe that's too granular, maybe that's not. It's a design call, I guess. But I don't know. I just have a feeling that it'd be bad to put the backup code in here. And, I mean, if we did put the backup code in here, it wouldn't be a completely disastrous decision, because, I mean, there isn't really much in here anyways. But I don't want to... I don't know. I just don't think it's a good idea. And I'm not going to do something just because it's the path of least resistance. I think that the path of least resistance is not always the best path, right? It's like if you're not I mean, this is kind of the opposite of Zen, but if you're not fighting your tools, then you're not an expert, right? Because I think that an expert is so particular about how they want things done that they're always fighting the defaults, right? They're always fighting and kind of like going against the grain, right? They're always taking the hardest way because they're so particular about how the things need to be. And, you know, maybe I'm wrong there, maybe that's a bad attitude, but that's kind of the opinion I've gathered. So yeah, we're going to make an insertion right here. We're going to call it pixel backup. And to do that, we'll just make some room here. And before we get ready to throw stuff in there, we want to make absolutely sure that everything's still compiling, right? Before we make this insertion. And the first step is just to stub in the files, right? So stubbing in the files is not a trivial deal in this system because I've programmed it specifically just to be very rigid. But that's the way I like to do things. So, okay, so we know it's working. So the first thing we want to do is actually create the files. So let's go and say that, Pixback .f. And these are backup functions for pixname. For pixname. Yeah, I guess we can just say for pixname. That's fine. Okay, so we'll take that and we'll go into our library where we are dumping everything without putting it into any folders, and we'll just say pixback dot functions dot underscore, and then we'll make a data file as well. And we'll just take this and we'll say pixback.d, and I don't anticipate having any data for this, but to add here to the patterns established in our codebase, we will... Okay, so I don't anticipate having any data here, but the overall pattern of this code base is that every single sublibrary or subsystem, whatever you would like to call it, has a data file and a function file. And we're going to keep that pattern, right? And, you know, sometimes one or the other may be empty, depending on if the library is supposed to function, depending on how the library is supposed to function, right? Some libraries have more of a class-like behavior. Other libraries are just function namespaces, and other libraries are just data collections, right? So, but for consistency, I don't want to make the differentiation between, you know, an enumeration, a class, and a function namespace, right? Like, I don't want to make the differentiation between all of that formally in the code. It's just you have to know what the different systems are used for, and if you don't see any data, then you must know that it's a function library, right? So let's take this, and we're going to call it pixback.d.underscore. So we got our data file, we got our function file. That's good. And we'll close that, and now we need to go into... well, actually, we got to go here first. So we have to define, and actually, we can just steal this right here, because that's a lot to type. And pixback for pixel backup. And it's going to back up and restore, but we don't really have enough room to say all that, right? So we could say backup and restore. And, you know, backup and restore is kind of a vague summary, but we don't have that many characters to make a summary, right? So these are kind of like high-level elevator pitches for what these things do. Also, pixname and pixback are very similarly named, right? Because they both start with pix. So it should be kind of obvious that when we're talking about backup and restore, we're talking about backing up and restoring this. But, you know, if it's not, no sweat. We'll add some documentation and all that good stuff to help address that. So with this, we're going to go up to 25 now. And then this library chain needs to go up 25 here. And now we need to find the libchan stuff. So we'll go into our lib, and we have a thing called libchan. And libchan bot and libchan top need to be edited. So let's keep bottom on the left, and we'll keep the top on the right. And we're just gonna... Oh, wait, my bad. That is totally the opposite of what I want to do. Reading top to bottom, we want to address the top file first, the bottom file second. And we'll just go through the library here and kind of rig in the new system, right? So we're gonna make another entry for here. We're gonna call it 25, right? A very obvious pattern, right? It's the library chain number 25. The libchan max is now going to be 25, right? Because these numbers just match. Very tedious, stupid things, but like I said, I like clarity. I'm trying to make very clear code, even though it's very rigid, and one of the downsides of making the code rigid is the pain that it can be to kind of like add new things to it, right? So now if we look for pixname, right, so we can go through all these different systems, and we can find pixname, and we know that we want to put pixel backup after pixname, and we know that pixel backup needs to come after pixname because it's backing up pixname, right? So it's going to reference pixname, therefore it must come after, right? So pixname is right here. So the first thing we're going to do is we're going to copy it, and we're going to paste it down here. And then we'll just replace pixname here with pixel backup, right? So pixback for pixel backup, .d for data. And the next thing we want to do is we want to change all these numbers. So this is kind of tedious, but like I said, we're going to make the code very rigid so that it's very understandable. And it's a trade-off, right? If we make our code kind of rigid like this, then there's a lot of tedious things that can sometimes happen. But I'm going to stick to my guns on this because I think I'm onto something. I think I'm onto something here. Maybe I'm just being completely insane as usual, but I've experimented with a lot of ways to put together a code base, and so far I'm kind of liking this method. And, you know, maybe I'm crazy. I could be crazy. I don't know. And at the end of the day, how crazy I am, it doesn't really matter, right? What matters is, do we get some working code, right? Do we get some working code? If we get working code, then we're fine, right? So let's see, paint 5D, and we have so we have the pixel backup. We got pixname, pixel backup, GPU data, and we should probably align that. Okay, so we got GPU data 19. We got pixload 20. Tau dirt 21, tau depot, tau type, tau sync, and paint 5D. Okay, so that looks good to me. Now, these are the data files, right? We include all of the data files before including any of the, what do you call it? Any of the function files. So we'll do the same thing here, right? We're going to look through here. And we're going to insert the pixel backup after the pixel name, right? So find the pixel name system. So here's pixname, and also let's align that. And we'll take this right here. We're going to paste it and change it. So this one right here we're going to change. So we're going to call it Pixback. And we're also going to get rid of this pattern breaker commentary because this is no longer a valid commentary because we changed the namespace for the pixel name thing. And also, even if that was a valid commentary, we just cut and paste, so it's not meant to be for that anyways. But yeah, we'll remove that commentary because the namespace, we originally had this double namespace. Pixel name used to be called AAC 2020 GPU data pixname. And I decided that that was a horrible idea, and so we got rid of that namespace. And also, even if it was a good idea, we changed the way GPU data works to make GPU data a temporary container only for passing around data. And so it would still be a bad namespace because of how we changed the behavior. So anyways, 18, we're going to go 19. This will be 20. Call this 20 right here. Call this 21 as well. And as we're doing this, we want to make very certain that the numbers in these defines are exact, because I'm fairly certain that this and this may not evaluate to the same define, right? Because defines are looking for text replacement, right? So they're looking for those exact values, and they're not really, as far as I know, they're just looking at the character values. They see a 22, but they don't see a number, right? Because it's just a preprocessor. It's just text replacement. So it's so we got to be careful with that. So 22, 23, 24, and 25. Okay. So now that we've like renamed, renumbered everything and shifted everything down, we need to go through some more of the code, because I made some contingencies to make sure that I didn't accidentally screw things up when I did this, right? Because this process is very error-prone to kind of slide things around like that. And so, in some of the code, I don't know if it's in this file, it all might be in the bottom file. It looks like it's all in the bottom file. So, in this bottom file, it looks like we did all those changes. So, the library chain order check. So, if we look at this, and we scroll down, we see Pix name right here. And we want to make the insertion here. So, we can see that it looks like there's a if, and two end ifs, right? So, we want to take that, and it's just cut and paste. Like, everything we're doing is just simple cut and pasting. And even though it looks very complicated, it's not complicated at all. It's just very redundant, right? So we'll call this Pixback. And then one thing I often forget is this token right here, right? These match. We got to fix that. We got to turn this into Pixback. Okay. And then after this section is done, which we can easily see that it's a certain section because of the right, there's a very obvious pattern here, and that's what I like about how I've written the code, just very obvious patterns. It might be a lot of stuff, but the patterns are all very obvious, and it's not difficult at all. Don't be afraid that there's a whole bunch of code here, because it's very dead simple, right? So don't be afraid of a lot of code. Be afraid of code that's hard to understand. This is very, what I would call, it's not dense code, right? It's very... This is like the fluffiest kind of code you could get. So if, do this error thing, and then end if. So we want to take this pixel name thing, and we want to make an insertion here. And now we have two of these pixel names. This one's going to be turned into Pixback for pixel backup. And we want to make this number 18. So we're going to copy everything from here with a column selection, 2 spaces, then drag right here, and then paste. Okay, now we can name this to 25, and everything should have been renumbered correctly. Okay, so now that we have this section, we want to continue refactoring, and we see that here we have a little note, be nice, avoid macro pollution of others code. So because it has a hashtag, I know that it is in the hashtag comments, so let's actually look for that, just because I'd like to see if that's actually there. And if we look, yeah, we can see the little note here. Don't pollute other people's code with macros. And I could see how these might be useful to other people using the library, but let's stick to a philosophy of Yagni. You aren't going to need it philosophy, right? So I'm pretty sure people who are using this source code will not need these. But in the future, if that ends up not being the case, we could take it out, or I guess the person using the engine could go into the engine code and remove these. I don't know. Generally, I don't want somebody using the engine code to have to edit anything inside the engine, so we'll see where that goes. So this is 17. We'll duplicate this line with a Control-D, and then instead of pix name, we want Pixback for pixel backup, right? And then we can take this here and Control-X, space, then drag here, and then Control-V, and now we have slid all those numbers correctly, and we can now append a 25, and now we have all that renumbered correctly. Okay, so that is everything we should need. Oh, actually, there's one more thing we need to do. For every single system, even if the system doesn't do anything on initialization time, we still want a, so we have Pix backup. So in the function file, even if it doesn't do anything, right? Even if there's, even if it's a data-only class or a data-only library, we're always going to have an initialization or an init none function. And the reason for that is consistency, and it's also so when we're looking at the main code, and we're seeing where all the systems are initialized, we can see that everything is accounted for, right? Even if it doesn't have initializer code, we can still see it's accounted for because we'll see the init none function. So we're going to do a U32 and call it AAC 2020 Pixback and then init none. And there is a very specific reason for why I named it the way I did. So it is called init none rather than no init because this is what our initializer functions are, and then we just append none on it. So if you look for pixelback, if you're trying to find the initialization function for pixback and you search for this, you'll be able to find this entire function. So you won't find the function you're expecting, but you'll find the function that you need to find, right? It's not the function you wanted, but it was the function you needed, like quite literally. Not the function you were searching for, but it's the function you need to know about. And so when you're thinking about the code, we want to think about how do we organize the code so that somebody new to the code base is going to be able to find their way around. Okay, so we're going to call this init none, and this is just a section divider, and this is just my habit of how I've been organizing the code, because so far I'm really liking this kind of style. It's like not too designy because I can get out of hand, but it's also very explicit, right? Like I see this section and I know exactly where it begins and ends because I have this convention of on the beginning we justify left, and on the right and on the end we justify right. So justify left at the beginning, justify right at the top. Okay, so now that we have this function, let's just stub in the basic behavior. So if U32 and reserved for future use. Okay. And then down here, we're just going to return 0. So return 0x00. And the reason I use 0x00 is to make it clear that I have in mind that we're going to return some type of array of flags, like bit flags or something, for the status code. Or we're going to somehow use the binary information to kind of bit pack multiple values together in here, where it's not just going to count as a number. Like this is not going to be seen as a number. We're going to think of it as a collection of bits, and that is why I use a hexadecimal value, and also why it's an unsigned value. Okay. So here we don't actually need any initialization code. No. Oh well, that's why it's called init none, right? So, and then no work was ever done. And let's just kind of like make a little video integer ID of where we are. So at vid integer ID, and the time is 37 minutes. God, really? Already 37 minutes? So 0 hours, 37 minutes, and 29 seconds. And that's actually kind of... Well, actually, no. We had like 10 minutes that we were, like 15 minutes that we were just waiting for the stream to start. So, okay, I'm not as disappointed, because I'm like, what? We didn't do much code. Why is it already 37 minutes? Okay, now I'm scared. Time's moving too fast. Okay, we have this, and now we made this library chain so that we could compile up to any given library, right? And always have a working project. And in order to make the main project code relatively clean and not too bulky, you know, have a high-level overview of what's going on, I don't want to have to wrap this init none function in a, you know, if pixelback is included, run this command, otherwise do nothing. Like, I don't want to wrap it in a big define at the call site. So in order to avoid wrapping this function call, where we use it in a big define, we're going to use some macros. So let's go into the main function file. So in the library, in main, we have the main functionality file right here. And we can actually see some of these things. So if we look at for init none, for example, we can see that we have these things called f macros and init and init none. So instead of the namespace you might have thought, like AAC 2020, it's called f macros. And this is because all of these function calls have guards around them, right? They're all macros, and so if the library isn't actually included, then these function calls do nothing. And that makes it so we can kind of very densely pack all these initializers in the order that they were included, right? And because if we did these function calls, the exact function calls, then we'd have to take every one of these, and this would expand to 3 times its size, right? Because it would need an if-def on one side, and then a end-if on the other side, and then the function call in the middle, right? To say, you know, if a glbind is included, an if-def, then call glbind init, and then an end-if, right? So that would make this really bulky. So even with adding all of this commentary here that says do not extract, and putting this here, we've only expanded the code size by a factor of 2 rather than a factor of 3 if we had to wrap everything here in individual defines. Now, we could just get rid of this commentary, but the reason the commentary is here is because if you're trying to search for where this function is called, you're not going to find the actual call site directly because it's wrapped in these f macros, right? So in order to be able to get close to that when you do a little control F, we put the names right here so that you can find them easily. So I'm going to take this init none, and I know it's going to be after pixname. It's directly after pixname. And it does look like I am missing some things here, because, you know, if this is 8, only 14, yeah, something's missing here. Oh, you know what? No, it's not the system initialization. It's just a big checksum of things here. I'm not sure if I like that now that I think of it. I think we should probably keep these numbers as the numbers of the actual system, rather than, like, we should keep these as the libchan numbers rather than just this 1 to whatever, because this is very arbitrary. But I get why we did that. We just want to make sure that if there's 15 things here, that there's 15 things here. We could get the same effect of a checksum if we just looked for the exact numbers of what these systems actually are. But let's see. So we put in right here pixload. We want to do pixback, right? So pixback. And then we're going to take this, and I should explain the keys I was pressing. I will do that next time. Okay, so at pixelback right here says it's 10, and what about pixelback here? Oh boy, did we not do that correctly? Oh, no, or did I not do it correctly there? Ooh. So I'm not paying attention because I put pixelback right after pixload, but that's not where it goes. So actually, let's fix the ordering of these things. So let's ditch this ordering here and say that ordering is kind of a bad idea. That ordering doesn't give us as much information as we could get if we reference the library chain. So let's go to where we're kind of like calling all these and look at the library chain, the top of the library chain, and actually not that, like this list here. So let's look at this list here and actually use the numbers from here, right? So it's not going to start at 1 here because we're not initializing all of those systems. We're kind of starting after the window code. So glbind, and then glbind is 11, and then 12, and etc. So 11 for glbind, glconst is 12. And we can just hand check to make sure that we're not missing anything. The CPU uniforms, so that is a 13. Is it a 13? Yes, it is a 13. The gradient quad is 14. Okay, 14, and our free space is 15 then. Is our free space 15? Yes, it is. Okay, frag bed is 16, so we'll put a 16 here. And pixname, what is pixname? Pixname is 17, okay. 17. And after pixname, we have pixback, which is going to be 18, so pixel backup, 18. GPU data is 19. Okay, pixel load is 20. And I am just doing a quick visual check to make sure everything is in the order that it needs to be, right? And, you know, I could just kind of column select all this and just paste it down there. But it's nice to, like, when you're back in a certain area, to just give it a spot check and make sure that it is correct. So tau dirt is 21, and tau depot is at 22. Tau depot is 22, so 22. And tau type is at 23. Yes, tau type is 23. And tau sync is 24. Tau sync, 24. And paint 5D is 25. Okay, excellent. So now we're going to just take all this, and we should be able to paste it right here, right? And yeah, so we still get the advantage of a checksum because we start at 11, we're consecutive numbering, and then we get to 25, right? And over here, we start at 11, consecutive numbering, and we get to 25. So as far as a checksum goes, this still seems like a valid checksum, and I think it actually gives us more information because we actually use the library chan order. So right here, what we might want to do is make a make just a notation where we just go ... or something, or you know ... I don't know, ... Actually, how about ... and then we'll just make more space here, right? So that it's kind of lined up nicely, but then we have this kind of ellipsis over here, right? To say that, you know, there's more, but it's not here. It's somewhere else, right? So we'll do the same thing over here. We'll kind of space that out. And I know I am getting designy, but, you know, blame me for going to art school, I guess. 1, 2, 3, 4. Okay. The next thing, what do we want to do next? Now we have enough room where we could probably say libchan. In libchan, maybe. Let's see if we have enough room. If we have enough room, we'll say it. So in libchan. Or we could just say, you know, a number in libchan, and maybe that's kind of like cryptic. I don't know. That is kind of cryptic. And that might actually be, I don't know if that's a good idea. Libchan, because we already, do we want, well, we're already using the word libchan, like, all over the place, so I don't, if we're gonna, like, you know, search for where libchan is, well, we're already using it all over the place, so it's not like we're gonna clutter our search results too much for, like, find in files, libchan, find all the results. It's already cluttered enough because we already have the word libchan, like, all over here, so it's not like we're doing too much damage to our ability to search through stuff, or no more damage than already existed. So let's just keep it like that. And we'll add it here as well, right? And this is just a little note where we have the extra space to use it, right? We have the extra column space here to say something extra, so why not, you know, say something extra that gives people a little bit more information about what's going on, right? Like, if there's that extra real estate where we can communicate extra information, then we're going to do it, right? Better more information than less, in all cases, I think. Okay, so now that that's there, we have to actually create that f macro, right? So we have we need an f macro for the pixel backup function, the init none here. So let's open up f macros. So there's a actual file called f macros. So f macros, and I did not realize we had a top and bottom file. So let's close some of this. Let's close this and this. Let's close all the distractions here. Hope that we got all that stuff right. And we'll even close this, right? We'll close this, we'll close that. And let's just look at the top and bottom f macros. We can close this and see what's in here. So we have some kind of random stuff. This is, what are these functions here? If it equals 0, we're not doing anything. And we're not doing anything here either, so what the hell is this for? Why did we do this? Oh, I see. So, you know, if it's included, we're just making absolutely sure that it's system number 5. So we're being a little bit more rigid than I think is a good idea. But since we did it, we're just going to keep it that way for now. until we kind of like change our mind and get fed up with this. So I keybox, Graquad. I don't think we did it for everything. I think we kind of gave up on this thing. We're like, you know what, this is too much. So here, what do we have? We got some init none functions, and then we have all the code that kind of like auto generates the init none function wrappers down here. So what we're gonna do is this is kind of the more functions we end up getting in here, the more nerve-wracking this becomes in terms of like, oh god, is everything accounted for here? So if we see this, we see 1, 2, 3, 4, and 5. So we should see 5 clusters of color. 1, 2, 3, 4, and 5. Okay, yeah. And are they all in order? CPU info, pixload, and then 3 tau things. Tau dirt, tau type, tau sync. Yeah, that looks like it's all in the order that I would expect it to be. So these are our initialization none functions. So we're just going to take all of that stuff and we're going to nuke it and just regenerate it. So we know that that pixload is somewhere after a pix name. So the order really doesn't matter here, but we want to keep the, even though the order does not matter and we could make it absolutely arbitrary, we want to enforce a stricter ordering than what is required. So we want to keep the ordering here as the ordering that they appear in the library chain. So before pixload, Pixback comes sometime before pixload. And yeah, we'll just do that. And then we'll take all of this code here, which is specially formatted for my shortcuts. So if I put all of this stuff on my clipboard and run a certain shortcut command, it's going to take this code snippet that's called source, and anywhere it sees the find and replace pattern, these stars, it's gonna, because it's the find key right here, it's gonna replace it with these different things. So let's run the farc command for find and replace clone, and there we go. We got all of our code regenerated, all nice and uniform. So I guess, you know, even though I hate Java and I hate how they bloat code with like their automated getters and setters, here I am doing some really automated kind of stuff and adding a whole bunch of bloat. But you'll also notice that we've kind of isolated all of this bloat into files kind of dedicated only to this bloat, right? It's kind of like hidden back there, where we just try to forget about it until we add more to it. Okay, so now that we've added the pixel backup stuff, we want to... oh, also, this auto-generating would only works if we're completely uniform in how we name our functions, right? Like, if we named one thing init none, and then we said init 0 and another thing, or don't init, and if we named our functions inconsistently, this would not work. So this is one of the benefits of being completely uniform, is that we can kind of batch out stuff like this. Now, in some languages, you would implement, I don't know, some type of interface probably. You'd say that, you know, it implements init none or whatever. And, you know, interface is just one of those things where you're just relying on some mechanism of the language itself to keep you from being lazy or keep you consistent. But if you're strict enough about your coding, then you don't really need those language features, right? But I think that C requires a lot of discipline because there's not like built-in mechanisms that are built into the language to keep you writing nice code, right? It's like all up to you to kind of like develop the framework of how you're going to write that code and how you're going to do it well. Okay, so loop tick, init none, and init none, and then init. Okay, so we got these different categories. Okay, I see. And it's going to be in our init none, and it's going to be before pixload. So we'll just do like right here, we're going to do undef, f macros, and pixback, init none. And I don't know if everything is accounted for here, because, right, we've clustered them into different categories this time. But the idea is just to clean up after ourselves, right? Where if someone includes our library code, even though these are very verbose names, it's very unlikely that they're going to collide with someone else's code. We still want to have good habits and clean up after ourselves, right? We don't want to like have a whole bunch of macros pollute other people's code. Another thing is, I don't know what the performance cost is, but I'm going to take a guess that if we're good about things and we clean up all of our macros and we don't pollute other people's code with a whole bunch of macros that they're not even using, it's probably a performance benefit. I don't know how much of a performance benefit, but it's probably some type of performance benefit. Or, well, actually, it's probably absolutely a performance benefit, but we just don't know to what magnitude, right? It could be completely inconsequential, or maybe it could be somewhat useful. I don't know. Okay, so now that we've done all that finding and replacing, it's time to like give this a run and see if we've made any horrible mistakes or if we've stubbed everything incorrectly. Have we stubbed everything incorrectly? And I don't know. So the first mistake we've made is pretty trivial. Let's go into the function we stubbed in. So the pixel backup functions, right? We have this U32, but we actually have to define what U32 is. So you might be like, well, why do we have to define what U32 is all the time? And the reason for defining what U32 is all the time, even though we use it like in all over the place, right? We use U32, I32, U08, we use those all over the code base. But even so, it is my experience that if I make a big file full of all the macros that I think I'm going to use in the project, it just ends up eventually spiraling out of control. So to prevent it from spiraling out of control, we always define our macros local to a section, right? If the macro does not have the name macro or mac in it somewhere, then it's a local macro and it needs to be wrapping a section, right? So this macro here is wrapping this init none section. And the reason for that is just like I said, we can get out of hand with our macros very easily. We don't want these very short macros to ever spiral out of control. So another thing is, even if our shorthand macros didn't spiral out of control and we kept them a pretty small number of them, we would still have to like open up another file to like see what this is. And that adds a lot of indirection, right? Because now we have to like physically open up another file to see what it is, when we can just add them here and here. And even if the list of macros gets pretty large here and here, it's just scrolling up and scrolling down to see what they are, rather than opening up another file. So as far as the administrative effort, it's a lot easier just to put them here. That is my experience. Okay. So let's give this a run, see what else I screwed up. And we have a static assert, include tau depot 21. Yeah. So my tau sub-libraries have all been shifted down, have they not? And so if we look at our library chain, right, so we put pixel back up here, and we can see that GPU data, pixload, definitely all the tau dirt stuff has been shifted down. So this should be in F macros. Is this F macros? Yeah, it's in F macros. We're gonna have to open up F macros again. And this is why I'm like, I don't know if, not the bottom, the top. This is why I'm like, I don't know if I like this stuff. It keeps on giving me trouble. So I haven't deleted it yet, but I'm thinking about it. Because I'm not sure if it's very useful. This kind of stuff. I do like the extra redundancy. That's kind of why I haven't deleted it yet, because I'm like, I'd rather have my code be hyper sensitive to changes than to not notice a code breaking change. So I'd rather have it falsely report that the code is broken than to not notice when the code is broken, if that makes sense. Okay, so we have this 14, we have this 21. Okay, so they are in a numerical order. And it looks like the only thing we gotta worry about is tau depot, tau depot is now 22. So we're gonna take this 21, just name it 22, and that's all we need to do, right? Okay. So now, if we give this a run, I think maybe we've successfully inserted everything, and it's just gonna compile. And oh yeah, that wasn't too bad. Like, it was a lot of like tedium There's a lot of tedium, but we got the new kind of system kind of stubbed in there. So now that we have it stubbed in, we want to add some logic, right? So let's keep this pixel backup file open. And let's try to find where we were doing that malloc code and whatnot, and try to find it and just make a generic utility for backing up code with, yeah. So, hold on. So, let's go and look for... Oh, hold on. So the problem with this pixel backup is that tau dirt actually needs to, when we're backing up all of this stuff, we actually have to make sure that we have access to, the dirty tree, don't we? Well, let's look at what's in tau dirt. What's in tau dirt, and what can we... Should we shove in... So let's look at the tau dirt functions. What do we have for tau dirt? So there is already a decent chunk of stuff in here. Yeah, yeah, look at all that stuff. No, we don't want to. And I mean, maybe a lot of this is test code. Yeah, I mean, there's test code and whatnot, but I would rather not expand on this at all. But I do realize that, yeah, we have this pixel backup, but when we're backing up this tau system to, like, poke and prod at it, we actually need another... we need to back up that dirty tree as well. And because we need to back up the dirty tree, we need... We need something that knows about the dirty tree, do we not? So that would mean the backup code specifically for tau would be between tau dirt and tau depot, right? Because tau dirt is the data... Well, what's tau depot? Tau dirt is the dirty tree. What is tau depot, though? So let's look at tau depot for a second. So tau depot... And let's look up the data and the functions and see, well, what is tau depot? Is it a function thing, or is it like a data thing? So we have a diagram, but tau depot. So misc section, knitted with, and then, okay, so we do have this, like, kind of like, okay, so I do see what tau depot is all about. Okay, so... One thing at a time, though. So there's definitely there is the possibility that it might make sense to have some type of backup code somewhere in here, but I don't know. I think we got too much of this tau stuff, and it's kind of hard to get a proper backup for all of this stuff in one spot, just because of this has data, this has some data, and you know, this has, I think this might even have some data as well. So to get a full backup of all of these systems in one place would violate this chain pattern we have going here, so I don't think we're going to do that. So I have another person who kind of dropped in. So here, let me just show you the demos. So my demos, here's my demos page of like some of the tech that I've been working on. I put that in the chat. And really quick, I don't know if you're new or not, so... let's just show you kind of like a quick kind of, we're going to show you one little animated GIF that I took a few days ago of what I'm working on. So let's open some stuff up really quick here. So in my, where are you? Where did I put that? I don't even know. I think I put it in my E drive and vital assets. And then, I think it's HD assets stack, yeah, AA1. Okay, so we're just going to open up one of these files, show you it. If you're there, If you're there, pick a number between 3 and 34. Otherwise, I'll just pick one out of a hat really soon. So let's just show you, how about, I don't know, let's, I think 28 looks kind of interesting. Let's show you 28 really quick. And then we'll get back to coding. I just want to show you one thing, and show you kind of what I'm working towards here. So let me go to GIFs in Windows Slideshow. So we got this game we're working on, and this is a game, well, this is a game I made in Flash, like, a long time ago. Like, almost, God, like almost 8 years ago, maybe 5 or 8 years ago. I lost track of time, but we're gonna remake the engine for this in C and OpenGL, and the rendering tech is going to be a lot different. It's not going to be pixel based. It's still going to be tile based, but not pixel based. So, anyways, I want to get back to the code. I just wanted to show you kind of like what we're doing, what we're working towards. So let's close that, and back to the code. So bottom screen. Okay, so we need to create some type of generic function to back up the data that we're testing. So the idea is that we back up the systems. Then when we test the systems, we kind of can poke and prod at the internals and run our tests and do whatever we want to the actual systems. And then once we're done testing the systems, we restore the data. So the idea is we don't need any type of mock object, right? We can mess with the actual system, which is better than messing with a mock, because the mock is never actually the real thing, no matter how much effort you put into making it like the real thing. And even if you could make it like the real thing, you still have to write the code for that. And right, it's much easier just to back up the stuff, test it, and then restore it. Back up, test, and restore. And that's the pattern we're going to go for. Okay, so we want to look at, I know the last place we were working on a lot of tests was in tau sync. So let's look up the tau sync functions and see if we can find where we're doing that backup and restore. So it should be pretty easy to find. So in tau sync.f, the functions, there should, if we just look for malloc, we're probably going to find it, right? Because we try to use malloc and free pretty sparingly, because it can be disastrous when you screw it up. And we can see, oh, we only got malloc here in one place, so that's good. And we can see this is a backup or restore, right? So we decided to label the section as backup or restore so that we could easily kind of find both the backup code and the restore code really quick, right? So we see this mem copy, and are we freeing or mallocing? So this is the malloc section, and then, are we going backwards? Yeah, we're going backwards, okay. We shouldn't be going backwards. That's what I'm getting, why I'm getting confused here. And then here we're freeing, right? So they're right next to each other, so I don't know why I was doing that. But you can see we back up certain chunks of data, and then we do our force clear that we also need to do on that dirty tree. So this is backing up the pixel data right here, and this is clearing the dirty tree that's associated with that data. And then after we do all that, we're going to run our tests, and then when we're done, we're going to restore. And also, you know what? One thing that we're kind of missing here, now that I think of it, is this force clear for unit test really needs to be done over here as well, because we need to, before we exit the tests, we really want to make sure that the dirty tree is correct. Now, it won't be that problematic if it's not. Well, I mean, we got, yeah, I don't know. It won't be that problematic if it's not, but we have to assume that, I don't know if it matters too much, but we should probably make the assumption that when the system is initialized, that it is zeroed out. And unless we do this, we don't have a guarantee that it's zeroed out. So let's just say that right here we're going to say the video integer ID is 1 hour, 8 minutes, and 39 seconds. And the time is, oh, well, that is the time. Jeez, I'm just not paying attention here. So the video integer ID is 0061, and then the time is that, right? So, zeroing out the dirty tree before exiting tests is probably a good idea, but also means we assume. But it also means that we assume that the system is in a zeroed state after we're initialized. We assume the system Okay, so that's just a little commentary of why we're doing this call right here. And I don't know if it's the best idea, and also maybe we could do like something like this, so we know that that video idea is kind of like, you know, it's not the best thing, but, you know, maybe that way we can kind of see that this is for that a little bit better. And the idea is if I keep the comment directly above this, it's a little bit hard for me to see the code, so keeping this empty space is nice, but then the code comment is a little bit disassociated with the code line, so keeping this little comment here like that so I can see that they're linked might be a good idea. Okay, so that's all good and well. Let's try to extract some of this to put it in here. So this is the mem copy, and then we have like this stuff. And we have, why do we have two things? What are the two things? We have backup 01 and 02. So what are the different things we're backing up? So we have, we have the dir any, and then we have the, oh, wait, okay, so we have the dir any, and dir any is actually our tree, right? Okay, so never mind, this is actually a horrible idea. This thing that I wrote here, bad idea, never mind. So this that I wrote here, this is, do not fucking do that. So let's do this. Let's rewrite this as, you know... Oh god, we disconnected, huh? So let's rewrite this and say, you know, do not do this. Restores code restores the tree. This, and then this would just zero out the tree, which might not be the correct behavior, the correct state. And then we'll do @vid integer ID and 0061, and then the time is 1 hour, 12 minutes, and 17 seconds. And this kind of goes off the line here, so we'll have to put this over here like that. Okay. So this is what I do when I realize I've done something wrong. I do a minus and say, you know, do not do this, right? And, you know, if we want to make it nice, we can just, you know, put some exclamation marks. Okay, so do not do this. Now this is kind of obnoxious, but the thing is that I almost wrote this code because I thought I was fixing something, and I almost broke something, right? So the idea is that next time I try to fix something because I think that's a good idea, I'll realize, oh wait, no, that's not a good idea. What the hell am I thinking? Okay. So this kind of backup thing, if we have the pixel backup code, it can't back up all of this, right? It can't back up the tree. And that's why, So I kind of like all of this, like, right here. Right, it's pretty readable. So I almost think that, you know, even though I have this here, maybe it was a bad idea. Because having the logic kind of consolidated, where we're kind of like backing it up and restoring it, like maybe that's good enough, right? And so we need the tau dirty in order to like properly back this up. So we would need to put it like between 21 and 22. If we like this kind of isolated kind of code here, and I kind of like it. If we want a proper backup function, it definitely needs to be between there. And so eventually, if we want some type of backup code for the other pixel name things, we definitely could do those. So since we're here, we might as well write what we're thinking about. And maybe it's a bad idea to write code that we're not going to use. Yeah, that is a bad idea. But it's not too much, so why not just kind of do it? So these different systems, let's do like a some generic backup code. So generic pix name backup code. Okay, so this is going to be the generic method, and then we'll have like specific methods that kind of like wrap this method here. Okay. And all we're going to do is back up these 512 by 512 pixel chunks, and backup, but we also need backup and it's going to have a backup and restore. So we'll do a void, and we'll do AAC 2020 Pixback. Oh, hold on. Is this even gonna work? Because we need, like, local allocations, don't we? We need... Like, right here where we're backing stuff up, we have, like, these mem copies and whatnot. And our backup allocations that are mallocked, right? So if we look at here, we're mallocking memory. These are local, right? And if we try to make a backup, a generic backup function, then we just have to like pass it stuff, and then it just gets really convoluted. It gets like this is even though this is like a big block of stuff and it's kind of like annoying and it's very clunky, trying to offboard this to a generic function might actually just be a whole bunch of code and make things a lot more convoluted than we want. Now, you know, we could be fancy and we could try to like solve it with like macros and includes and like get all really fancy to make this like reusable, right? We could do a lot of really fancy stuff to try to make this code reusable. But when I'm looking at this, I'm thinking it might be too hard to make this code reusable. Because what is this going to require? What is it going to require to generically back up a file scope array, right? We're going to have to like give it a pointer to... we're going to have to give it a pointer to the file scope array. Then we're going to have to give it a pointer to the temporary array. And then we have to, like, run, you know, malloc on it. Then we gotta, like, run free on it. So, I don't know if it's a good idea. I think that what we'll do is we will... Why don't we just write it and see if we like it? And then we'll go from there. So, right here, let's do a Pixback and say backup. And then it will take a UO8 pointer, and we'll call this one file scoped data pointer. file scope. We'll call it non-freeable. Okay, this is non-freeable right here. And then we'll use like U08 pointer. And it needs to be a pointer, doesn't it? See, this is why I think this is just a bad idea, because we have to give it a pointer to the data we want to back up, but then, if we really want to do this nicely, we gotta, like, do a pointer, right? Because we want to, sure, well, why don't we just try it? I just don't know if this is a, pixname, backup. Non-existent backup. Yeah, so we would need something like this. Sometimes what I do is I divide the pointer like that and do like by ref, non-existent backup. And then here we can kind of like, we can say that, you know, we can do like, define and siz, and that's size of pixname file scope data. And then down here we'll undef that, size. And then we can do a, we can take this non-existent backup, right? And we can just kind of dereference it. And so it's now just a pointer, right? And it equals our malloc, right? And we have a malloc with the size, malloc, and the size, right? And it looks like we all already actually have enough room where we can kind of, even though that's kind of a very long name, it looks like we have enough room where we can do that, right? So just a backup, non-existent backup, and then here's our file scope data. So that's how we back it up. And if we want to restore, all right, let's do a restore. So void AAC 2020 Pixback restore. We're going to do the same thing with the U08 pointer. And we're going to still call it, we're going to give it the exact same names. Okay, the pixname file scope data. And then for this thing here, do we still want like a double pointer like that? I don't think we do, because we're not going to mutate it, right? We're just going to take it and, yeah, we don't need that. So we can now just say that a U08 pointer, pixname, original data, right? So, yeah, I don't know. These are kind of horrible names, but let's just go with it. Okay, so for the, and let's do like a little dash line here. So dash line I1 x64. Okay, so restore, we're going to instead of a reference, we're just going to say, you know, this is the original data. Pixname existent backup, right? Because now it exists, so we can throw it in like that. Get rid of some of this space here. There's way too much space here, so write that like that. And the next thing we want to do is we want to do our like malloc. We want to do our free. We want to like mem copy and free, right? So mem copy and free, right? So the destination is on the left because it's kind of like the whole like left associative aspect, right? So this is what we are copying to, and then over here is what we're copying, and then here's the size in bytes of what we're copying, right? So I noticed that we have the size of pixname file scope data. So if we keep this macro and we keep these names exactly the same, then we can get away with using this same macro for this other function, right? And so there's a lot of rigidity with how I'm using my macros, right? Where if we don't keep very specific names, things will immediately break on us. Okay, so let's do the mem copy, right? Because the idea is, and also we should have done a, we need a mem copy up here as well, don't we? Yeah, we need like yeah, we're not doing everything we need to do here. So right here, we need to do a mem copy of, so we created our pointer, right? And now we need to do a mem cpy, and the destination is going to be our backup, right? So this backup here that has been assigned to a valid memory location, we're going to use that valid memory location. We actually have to dereference it because remember it's a double pointer. And then after that we're going to copy this data, right? This is what we want to back up here. So this is already a pointer, so we can take that. And remember, it's left associative, so we're going to take this and we're going to copy it into here, right? Okay, so once we've done that, we would need to know, well, what's the size? Like, how many things are we taking, right? And we already have the size, so we can just use size again. And there we go. So now we've malloc the memory, and then we've copied it over to the backup, right? Which we called it non-existent backup because it doesn't exist here, but it does exist at this point, okay? So now we need to kind of look at this, do the same kind of thing, but we want to mem copy it before we free it for some obvious reasons, right? So we're going to do a mem cpy. We're going to take this, and we're going to copy from here, right? So left associative. And then we're going to make sure that we take the correct size in bytes. So siz for size. And then we want to free. And we're going to free the pixname existent backup. Okay. Now, I could see a reason to like do a double pointer, because then when we free it, we can null it out, right? So it's not accidentally used, which wouldn't really matter too much. And then it could have the same exact signature, which could be kind of nice, right? Because it's the same signature, which I kind of like that uniformity, right? We could call it, I don't know. I don't know if that's, if we want to do it that way. Because then we're taking, like, this double pointer twice. But it would be nice because then we could zero it out, right? Because we free it, but then we could set it to null, right? It's going to take the memory address and set it to, yeah. So what we could do is this. We could do like a byref like this. Say byref this thing, and then this existent backup, we're going to dereference it once to get to the actual memory address. And then when we free it, we still have to dereference it, right? So we dereference it because it's a double pointer. So to get the single pointer that we're going to free, we can write it like this, right? And the advantage of that is now we can change what this pointer is within this function, right? So we can free it, And then we can also set it back to 0, right? We can turn it into a null pointer, right? And if we don't give it a double pointer, we can't null out the pointer like this. But now we can. Now we can actually, right? Because now we can dereference it and assign it to null, right? Equals void pointer 0, right? And then bam. So now we are able to free it and then zero out that memory address, and that will be seen from the call site. From where we call it, it will actually turn it to null, which is kind of nice. And also the signature is the same now. So I think I would like to keep the same name for both of these. So let's not call it non-existent backup. Backup double. Let's call it backup double pointer. Byref backup. I don't know. Yeah, I think just keeping them the same names in both functions will just make it easier to see what we're looking at. Alright, because then we can see that memcopy, we're copying from the backup, and then here we're copying into the backup, right? In backup, we're mallocking it, and then over here we malloc, and then over here we free the backup, right? So I think byref backup is better there. And then, we'll call this a pixname. We could call this pixname pt data. Yeah, I just like everything to kind of line up. So because I'm OCD like that, so we'll do that if that's the way if we can get it there, then we'll do that. So and also this needs to be that. Okay, so so this is file scope var non-freeable. So at non-freeable file scope var. So this is a non-freeable file scope var, and this is reference to a pointer. I like to call it a reference to a pointer, because that is kind of the behavior we're trying to get. We're trying to get like the C++ behavior of being able to pass something a reference, right? Instead of pass by value, a pass by reference. But really all pass by reference is just adding another level of indirection. But you can't dereference a reference in C++. So a reference is really just a pointer that is not allowed. Did I say dereference? I mean reassign. You cannot reassign a reference, right? So technically this is just a reference to a pointer. And we should probably, since we have these double pointers, we should make sure that we're going to do this. We're going to say that, you know, if void pointer 0 equals pixname data. Let's just do some asserts, because I'm tired of, like, specific errors right now. So assert, and then not equal to, right? So make sure this is not null. And then the other thing we want to do is, you know, make sure that the byref is not null. And then the other thing we want to do is the dereference also should not be null at this point. Okay. And once we're done, we actually want to assert that this dereference is actually null now, right? We took because we had a double pointer, and whatever that resolves to, we actually want that to be zeroed out at the end. So after this, we're going to assume, we want to also assert that now, when we dereference this, we actually want to assert that it does equal, that it is nulled out, right? And so since we have like this kind of wrapper code now, we can say copy backed, copy backup data into file scope var, right? So copy backup data into file scope var. Copy and, let's not do that. Let's just call it, say, copy and free, because that's actually what we're doing. And I want to just create this a section that also encompasses the free. So we'll just call it copy and free. And let's see, what's my stream time? Live. Okay. So, yeah, that's another reason why I can't use my session thing, because the session restarted because I got disconnected. So, yeah, we'll call that copy and free. And then over here, we'll say that this section right here, we need some more of these asserts, these nice asserts here. But the asserts aren't going to be the same here, because what we actually are expecting is that the pointer does not actually point to anything yet. So this backup pointer, we're expecting the reference. References can never be null. So we're expecting this not to be null, but we're actually asserting that this actually equals null, right? So, so at ref never null, we'll just do n nil for not nil. Let's go into our little documentation and write, like, well, that's kind of cryptic. What does that mean? And then we'll kind of like, kind of give an explanation of what that is. Refs never nil. References are just pointers that one can never be nil/null. Two can never be reassigned. We can mimic C++ pass by reference by using double pointers. Okay. So that's just a little note of like what this means, right? Usually, such double pointer will be named byref underscore whatever byref whatever pointer we are pointing to, etc., right? Okay, so I have to take a quick break because my medicine's kicking in. So let's give it like a 15-minute break. We're gonna come back and kind of finish this backup restore code, and then we'll be done. Right? This is just a quick session. So let's go over here. Uh, well, no, I'm gonna be back. I gotta go. Okay, so I'm thinking, and some of the things. Oh, let's get rid of that. I made some mistakes here. First of all, the size, bad idea. Um, so first of all, I don't even think the size of operator would work properly because it would just take the size of the pointer, not the size of the data. Right? Yeah, that's not what we want at all. So let's get rid of this size thing. Let's get rid of that. And yeah, let's just completely get rid of it. And for the size, we just want to input the size, right? So we want to actually do like a int32 and just be like a size of data, right? And then size of data, right? And then over here, same thing, size of data, and then over here we're gonna do I32, and we'll call it, you know, size of data, right? You know, measured in bytes, which is obvious to anyone who knows a little bit of C. Probably already knows that this is obviously this is size in bytes. And some people are gonna kill me for, you know, not using like a size type or whatever, but I don't, you know, give me a good argument as to why that's a good idea. I know my allocations aren't very large, right? They're only like 512 by 512 bitmaps, which is pretty small in these days and age, and I'm sure int32 can address all of that memory, so I don't see why I would need a different type, and I like to keep things as unabstract as possible. Okay, so this backup, this is also a reference, so we might want to keep that there as well, or put that commentary in there as well. So reference to a pointer. We have at reference to a pointer, so we should make a notation about, well, what is at reference to a pointer, right? So at reference to a pointer, and then kind of describe, well, what is that, right? So let's take this, and we'll say that, oh, or we won't, because we can't type. Okay, this is, just means we are passing a pointer by reference. But C does not have C++ by reference parameters. So we just use a double pointer and make sure, one, the pointer can never be null. Okay. So we got this reference to a pointer. Let's go back here. Now that we have size of data, this will be fine. And we have these utility functions, right? We got this pixname backup code, and we really could use this for things other than pixels, right? Because this is the measured in bytes. And yeah, we could use this for other things, right? So that tree we need to back up, right? We need to back up we can see we need to back up the CPU pixels, but we also need to back up that tree here. We could use this function, these backup and restores, to do both of those things, as long as we know the size of what we need to back up and restore. So this could come into use already. Before we go any further, though, we need to just make sure that this nonsense that we wrote kind of runs, right? And then we're going to hope that when we tuck it into here, like when we take out the stuff that we already did, that it still works, right? We're going to try to shim in the new code we wrote and see if we can get it to work. So we have these unknown types, and that's because I forgot to create the defines for those. So if we look at this, it's just I32 and U08, so define U08 and also define I32, right? So define both of those. And once we have those defined, we're going to go down to the bottom and then immediately undefine them after we're out of this section, right? Because we don't want our defines to get out of control. And I've written a few code bases in C already. They were nothing spectacular, but my defines always got out of hand, so, you know, we declare them for a section, and then we immediately undeclare them. That seems to be working for me so far. Okay, let's give this a run and see what happens. So we got pixname data, undeclared. Okay, so that's because we've been changing things around and not being very careful, huh? So pixname data, memcopy pixname data. Oh, right here. It's right here. So pixname data. We can even see that it's not correctly aligned because we like took a lot of time to like make things that align properly, which is probably like a something that being way too OCD, but I like that everything aligns, so I'm gonna think about that kind of stuff. So 34, same problem here. Pixname data, yep. So no underscore pixname data. Okay. All right, let's give that a run and see what we got. Okay, so program's still running. And so the kind of assumption here is that when we kind of replace this kind of backup code with our backup utility, that you know, everything is still gonna work, right? That somehow it's still gonna work, right? So what we're gonna do is we're going to these are the two things that we actually need to back up and restore. So let's just kind of like make a very obnoxious comment and comment that out. And then we'll take our backup stuff and we'll say, well, this is the backup, right? And we need to take the backup. Well, we want to take what we're backing up. So let's see, what are we backing up? We're backing up this. So this is what we're backing up. And we're gonna, this is going to be our backup variable. So we need the address of the backup variable, right? Because this is a pointer, right? It's a pointer. But we want to... Oh, okay, so that's interesting. So... let me think about this. We could technically use it to back up yeah, we can just get really dirty with it and just do some casting. And rather than make another function, I think it'd be better just to... Right, rather than make another backup and restore, I think just a dirty little cast might be good enough. So let's do like this back, and this is 001. And then we need the size of these. So the size of this allocation here is the CPU pixels. And it's just, this is the size right here, right? So this is kind of ugly, but it's less lines than what we had before. Even though it looks kind of like, ooh, that's bad. And this is back 001. If it's, these need to match, right? That's the whole point. And let's just take all this, and we had back 1 and back 2, so we should actually just take this because it's wrong. We got the numbering wrong here. So these should be 1s, and then back 1 is for the tau dirt any. So we can take this, and we can just do the size of that, and we could just do the size of kind of like in place, because I think we got like way out of hand with those macros. Right? You can just put it right there, and that's fine. Okay. So if we did that correctly, right, and we're not using the restore function yet, but this should work fine, right? We don't have to call the restore because we already have this restore code here, and they should be compatible with each other, right? If this does not work, if we get some type of seg fault, then or some type of runtime assertion failure, then it's not the problem of, like, that means we wrote something over here wrong, right? So let's just take it, let's give it a run and see what happens, see if I know how pointers work or not. Incompatible type argument. Okay, yes. Okay, got it. So, now that's just because, when we took the address of this, it does not like me trying to back up this one because both of these types they're not the correct type, right? And I think it would just be easier. We really want to use this for other things, right? Because you could really use it for other things as well. I think we might want to just make these void pointers. Like void pointer and void pointer, right? And that way we don't have to think about, oh god, it's not compatible, right? We're just backing up data, right? We're just backing up bytes. We don't care what they represent, right? We're doing these mem copies and these frees. We do not care at all what the data is. We just care how much data there is and where the data is, right? So I think that this was... I get why we want the UO8s because, you know, that's the data that we're actually backing up here. But to me, it doesn't really make sense to... doesn't really make sense for me to, like, rewrite this code for other things. Maybe it does, but kind of doesn't, right? It's called Pixback, but it can back up other things. Kind of like how, I think mem copy is inside of string.h, because even though you're backing up bytes and strings are kind of like interchangeable, because strings used to be bytes, because ASCII is only 7 bits, so you use bytes to represent ASCII, and so string utilities and byte utilities are basically the same thing. And so we could kind of think of this as, you know, it's called Pixback, so we have a specific implementation in mind, which is backing up pixel data, but we can use it to back up any data that we want, right? So it's a backup utility. It's a backup utility for backing up data, but it can be used for anything, right? And maybe that's a bad way to go. I don't know. I think that's the way we're gonna go, though. So this could be a bad idea, right? We're gonna go with it. We're just gonna roll with it. So we're just gonna take these, or make them void pointers and void double pointers, and we're just gonna give that a shot and just see what happens, right? So we're just gonna take more of the safeties off, and then maybe shoot ourselves in the foot later, right? Error: incompatible type argument 1 of. So wait, that's still incompatible. Void pointer. Do we still have to cast a void pointer? Hold on. So back... Oh, wait. We have to take the address of that. We never took the address. So, yeah, we have to take the address of... Oh, did we put the reference in the wrong place? I think we did. If we look at this, yeah, the lowercase... The lowercase has the address on it, and not the uppercase. So we screwed up this royally, and this is why we commented out like this before we wrote stuff down here, because we thought, hey, maybe we're gonna screw this up, and we did. We totally screwed this up. And the lowercase is the pointers, yeah. And if they're the pointers, we don't have to take the address because they're already pointers, right? And then these guys here, the uppercase things, these aren't pointers. Well, actually, this is a pointer. So back to doesn't have an address. Oh, back to, we're kind of like doing this kind of thing, so it makes it a little bit more obvious. Okay, so what we're going to do here is we're going to do like at back like this. And then for back 2, we're going to do and then back 2, and then we're going to take a 0 here like that. Right, just to make that more obvious. And then we're going to try to get this all in one line eventually, right, by doing like a little define, make the function kind of shorter. But first we just want to get it working, and then after that we'll see what we can do. So, oh, and also we just forgot to clean up after ourselves, didn't we? So the uppercase is what we want to keep. With the ampersands, or, not ampersands, they're, yeah, they're ampersands, yeah, they're ampersands. So no ampersands on the lowercase stuff, because they're already pointers, and then, like this. Okay, yeah, cool. So even though I'm throwing around void pointers, the compiler is still catching me being dumb, so that's good. Oh, you know what? Hold on. Incompatible. So it's a void pointer. Oh, no, never mind. Because we changed this, right? So these are both addresses, right? But this needs to be a pointer, right? Because you're taking these addresses, and then we're taking the address of the address. Okay, so I see why I wrote it that way. Okay, right? So it's not exactly the same thing as... Okay, I see why I did that, right? Okay, because these are double pointers right here, and these are single pointers right here. Okay, I see. I can't believe I keep on screwing this up. And that's kind of the idea, like, if I'm kind of screwing this up, if I write a generic utility, the hope is that I'll have less problems. So, I'm gonna guess that, that it doesn't like it, because it's not like a double void pointer, it's more like a, okay, screw it. We're just gonna keep an explicit typing here, and we're gonna try to get this first line to compile. We're gonna put this one first, and we're gonna backtrack on this because this seems kind of cumbersome in how we'll have to or like do all the casting and whatnot to get this to work, because we're gonna have to, like, it looks like we're gonna have to cast like a void pointer to get this to work, and I would rather not do that. So I'm gonna take back what I said about like doing the void thing, and we're gonna take it back and make them U8 pointers and U8 double pointers, right? And then we're gonna see if we can get the compiler to fail here, and then we'll make a specific implementation for I don't know what we'll do. I guess we'll do some fancy casting. I don't know what we'll do. Or we'll only back up the pixel stuff using this method, and we'll have to create another backup thing for the tree stuff, I guess. So let's try that and see if we can get it to fail on the next section. So back 01 it's failing on, and is back 01 the second kind of thing, or are we still kind of stuck on the first thing? No, it looks like we're stuck. So we got through this. And for this backup 01 thing, we're going to comment this out. And we're going to take this anything where it says back 01, we're going to keep that. We're going to keep that method for backing up. So we'll keep this here because it has the back 1 on it. And then this back right here, we're going to keep that as well. Okay. So now we're hoping that it's going to compile correctly. And I guess we'll just use this for pixel backup, and we'll just write very similar code for backing up the other stuff, even though it's kind of, I don't know how I feel about it, but let's just do it. So, okay, so we're hoping that we won't seg fault right here, so let's see what happens. Okay, so that's pretty promising, I'd say. Though I will tell you that I am kind of scared looking at that code. Scared that, what if we screwed it up? So, I don't know how we could really test to make sure that we didn't absolutely screw it up. But I mean, a lot of the things we did, right? I mean, we're pretty careful, right? Right? We got all these asserts here, right? We asserted that both of these are not in our backup. We asserted that both of these are not void, are not null, right? The first two things shouldn't be null. And then we made sure that the initial input right here was null, right? When we When we dereference this double pointer, it points to something that's null, right? And then in here, we made sure that everything was non-null. And then when we freed it, we made sure that, you know, it was null after freeing it. So I mean, so we did our due diligence here. And so I'm fairly confident that, yeah, I think we got it right. Now, maybe we didn't, and maybe I'm just, you know, shooting myself in the foot horribly, and we're gonna find out. I don't know. So now that we have this kind of functionality, we can go down here to where we're restoring, and we can call the restore on the CPU pixels, which is the back 002. So on back 002, anywhere we see back 002, we're going to comment that out. And we are going to add the correct code for restoring, right? And this is kind of ugly, but you know, it's gonna get uglier. It's gonna get even uglier before we've kind of made this kind of like refactor. So we have this restore function, and we'll just say, you know, Pixback restore, and we'll take the original allocation. So this thing right here, the all capital things, we're gonna do the back 0020 like that. And then we're gonna take and back 002, right? Because we're gonna do the double pointer, right? We're not gonna just take the single pointer. It's always a double pointer. And then we'll take the size, right? And the size is just this like 512 times 512 times 4, right? We'll just take that actual size like that. We'll hard code it in there. And if we've got that correct, we should just see everything working nicely and no weird side effects or seg faults or any of that badness, but we'll see, won't we? So, okay, so it's working. I mean, maybe, I'm scared, because, you know, I don't always get that tricky with pointers, so it's like, I don't know. But, I mean, pointers, how do they work? I guess I kind of know how pointers work, right? So this is a complete disaster. And we really need some generic backup code for some other stuff as well. What I would like is, rather than kind of like make this kind of like, so what I think would be nice is to have, like a backup and a restore for specifically for Tau Depot, right? So, specific restores, so specific backup and restore, right? So we'll have like a specific backup and restore code, and within here, we will try to kind of wrap this kind of functionality into something a little bit more friendly to use. So we'll do like, what I'm thinking is something like void and then AAC 2020 Pixback. And then we'll call it backup, right? If we're going to call it backup and restore, then we should keep that same naming convention. But then we're going to overload it, and we're going to say Tau Depot. Or, actually, no, not Tau Depot. Yeah, actually Tau Depot, because it's going to be the Tau Depot pixels. So, Tau Depot. It's going to be those specific pixel allocations. And then within here, we don't need to know... We no longer need to know the size of the data, because Tau Depot has a size that's kind of hard-coded into the project. And we do need a backup allocation, but we don't need the original pointer, right? We just need the where we're backing everything up to, right? So we've eliminated, instead of 3 parameters, we just need 2 parameters, right? And then within where we're calling this, we just need to wrap this, right? So we're going to take this function here, this, actually, not the restore. We're going to take the backup function right here, and we're going to hard code it for, well, what are we backing up, right? So, we can keep the commentary, that's fine, and the pixel name data, right? So we want a pointer to the pix name stuff. So if we look at pix name, we can kind of see, oh, here's our pixel name stuff, and we can just go and then take pix name CPU pix and take the first slot of that, right? Bam, we got the thing we want to back up, right? Oh, that's wrong. We were doing tau depot, not pix name, so this one right here. So let's just copy that. Pix name, okay, yeah, our tau name got, tau depot, okay. Now that we have this, we need the backup allocation. This is going to be provided for us. So just kind of like throw that in there. And we can make a note that, you know, it's a reference to a pointer. Yeah, that's fine. I mean, yeah, we have 2 comments here, but whatever. That's fine. And the size of the data, measured in bytes, we know that that's 512 times 512 times 4. And my old boss would be proud of me for hard coding the exact numbers in here instead of putting it in some type of file to look it up, even though everywhere else I'm being pretty a little bit more convoluted than I think he would like. But since we've decided on a very bold design choice to say, you know, it's always going to be this for all of those memory chunks, and we've hard-coded it everywhere else, 512 times 4, we can just keep that up everywhere, and it's not a problem. Until we actually want to, if we ever wanted to redesign this system, well, first of all, different data, different problem. So let's not worry about, oh my god, what if we want more data? Different data, different problem. Also, remember, the more data we make, the more data the artist has to populate. So it's, we want something that's actually manageable for them. So I think 512 by 512 is plenty in terms of pixels to populate. When we're talking about, like, the fine precision of pixel art. We're not talking about, like, making a painting in Photoshop. We're talking about, like, every pixel counts here. Okay, so that looks about right to me, right? So it's a specific backup function. And all it needs is this, right? It's just going to wrap that, and we could do an assert here. We could do assert here, but we already have the assert down here. I don't know if we get any extra benefit from doing an assert there. But, you know, we could, but knowing where things come from is kind of nice. So, like, we could say, like, you know, if, you know, void pointer 0 equals, by ref backup, then, ERR, I don't know. I'm out of room to, like, write a specific message. I'm just gonna do, like, the current date and then, like, an A, B, C, or whatever. And, you know, we could do this, right? So, this thing right here, if we dereference it, then we're going to expect that it is actually equal to null, because this is the point that we're going to populate it, so we want to make sure that it's not equal to null. We want to make sure that it is, if it's not equal to null, if it's not void, then it's a problem. We need to make sure that this is not null, but when we dereference it, we actually want to make sure that it's null. So, so now we're, like, really out of room. So, I don't know. We'll just say Pixback 1, right? We'll just try to, like, say Pixback 1 and Pixback 2, etc. So for each new error, but then, you know, we can only go up to 9, so that will be a problem eventually. Let's just do 0 like that, right? Pixback 0, 1. So very dense, but something we can grab onto. Okay, so the restore function is going to be the same kind of deal. So we can take, let's just take this and kind of cut paste. And instead of backup here, we're going to call it restore. And it's only going to take one parameter as the previous. And it's going to need to take the restore function, which takes all the same kind of parameters, does it not? Yeah, it does. So the nice thing about keeping our functions nice and symmetrical is for the restore, we can just pump in restore here, and we have like everything we need already in place. Like everything here is in place. The only thing that's not correct is that now we need to make sure that, you know, this should be non-null, but then this should also be non-null right here, right? And then at the end, we could also make an assert to say, you know, this right here should now be null on exit, right? So right here, if this is not equal to null, then we have a problem, right? Because when we pulled it in here, then it should have ended up null, right? So with these error messages, we can say this is now error number 3, this is error number 4, and this is error number 5, right? So we're just trying to wrap all this code into some type of easy, like, reusable thing. Though I don't know. I don't know if this actually helps or if it just adds, like, a whole bunch of convolution to what we're doing. Like, right? Like, is this better or is it not? Well, the better aspect is, you know, once we have this kind of reusable function here, and we know that we've done the math correctly, and we've done our malloc and freeze correctly, then when we use it, wrap it in a utility, we're more certain that we haven't screwed up, right? So that's the advantage here of making this kind of reusable thing, is just that, you know, we only have to get it right once, and then we can kind of be more certain that it is correct, right? So I don't know if that's the best way to approach the problem that we're approaching it here, but, you know, let's just go with it, and yeah, let's just go with it, because I think that, so specific backup restore, I think that we're actually going to label this. So we're going to say tau depot like that. And then down on the bottom, we're also going to label this as well as tau depot. And the reason for that is because I imagine that for anything that we want a specific backup and restore, we're going to have to, like, kind of cut and paste, and it's going to get very verbose. And so it's like, I am kind of questioning if it makes sense to make these wrapper functions, or if we're just making it harder to understand the code. And I don't know. I don't really know. I mean, I don't know if this is a good idea or not. I just thought, hey, this is a thing that I think makes sense to put in this one place. Let's give this a run, make sure that it still compiles, and then let's try to swap out for these more specific backup and restore. So, unknown type name U08. So, in here, why is there not U08? It's because it's only in this section. We have to declare that. So, the size here is hard-coded, so we don't need an int32 type there. It's hard-coded in there. So, yeah, we'll just define U08 here. And then down here, we'll undef it, right? So you'll do undef and then U08. Okay, so now that we have that, let's give it a run and see if everything is working as we expect, right? Error, so there's no error function, right? Because this is a new thing. So let's do, up here, we're going to do halt is typically the first function. And 489 paste, so 489 paste. Okay, and let's do like I don't know, 111. Let's do that. And then we just have to paste in the current system name, so Pixback, And then over here, Pixback as well. And I really should change the snippet. Pixback. And... because this needs to be lowercase. And I keep on... I mean, it's not a big deal. It's not like extra typing, but it adds up. So let me try to edit that for a second. Edit 489. How about 489 edit? 489 edit? Yeah, 489 edit. Okay, edit file. Okay, we're gonna edit the file, and so I'm looking at the file on my other monitor right now. I'm just fixing it. AAC 2020. Okay, yeah, save that. Okay, cool. So now I just fixed my snippet so that if I paste this again, like if you see me paste it again, like 489 paste, right? You see, hold on. You see that now this is lowercase, right? So less typing to stub in the function that we need. So Pixback halts, and this is like the fatal error telling us where it came from, and then the specific error message flushing the output so we actually see the error message before we terminate the program. So this right here needs to be assigned to a macro called ERR for error, and this is just the standard of how I do it. So right here we'll say define ERR and then paste the name of our halt function, and then here we're going to undefine it. Okay, so let's give that a run and see what we got here. So we're not actually using the new function we just created. We want to make sure that, we just want to make sure it still compiles. And then once it compiles, now we want to try to swap out the backup function, right? So we have this backup and restore. So this is the restore, this is the backup. And what we want to try is now we think that we can get away with just this Tau Depot backup, right? And Tau Depot backup Tau Depot just needs where we're backing up the stuff to, right? So so when we back it up, it's going to take a pointer, and that pointer is going to be where the allocation is going to go. And then the restore is going to take that same pointer and free the allocation, right? So right here we can do and back 002, because it's going to take that double pointer, create the allocation, and back everything up. So once again, we do not have to call the similarly named restore function yet, because the behavior should be the same, right? So even though we haven't called the restore version, this code here should be suitable. It's just the unwrapped version of that code, right? So we're expecting that this should work, and we just want to add it in step by step in case we made some type of catastrophic mistake, right? And we want to catch that catastrophic mistake as soon as possible. Now, if we do some type of undefined behavior, we're completely screwed. But, if we got this right and we're doing things correctly, then we're in some good standing. So, looks like that's working. So then, down here, we can take this Pixback restore. And what happens if we do not restore it? I'm just curious. Does that mean we're just going to get... are we going to get the colors? The colors aren't going to be there anymore because they're going to be black, right? I would assume that the shader would just be black. Or we're not going to see that magenta anymore, is what I'm assuming. Okay, yeah, so we got we got some weird stuff going on over here, right? Like we were doing some stuff with some tests, and then we never restored it. And you see these little dots in these certain locations, right? These 4x4 pixel clusters, which correspond to kind of where we were setting values on the texture to make sure that things were working. And that's fine. I'm kind of concerned that there's not complete coverage here, but we probably cleared things a few times and then kind of redid the test, and this is probably the last test we ran or something like that. So yeah, we can kind of see some evidence of our mucking around with the data there. And if we run our restore, we're going to assume to not see those dots anymore, right? So if we run this restore function, we're going to assume we're not going to see those dots. So let's take this restore function, and let's give it the and. Don't know what, so and back 002. So we're going to give it that backup that we just commented out here. So we're going to give it that backup variable, right? The, back 002, and then we look at back 002, it is, oh wait, hold on, is back 002 the thing we commented out? Oh no, it's right here, it's back 002, it's tau depots pixels, so that is correct. I'm just making sure here. And yeah, so the restore function now is a little bit less, this was kind of clunky, this is a little bit less clunky, but obviously we're hiding a lot of, like, wrapping of logic. And if we run this, let's see if that gives us originally what we had, right? And if it does, then I'm kind of confident it works. I'm kind of scared, but that's because it's C code and we could shoot ourselves in the foot. Okay, yeah, sure. I'm good with that, right? Now, this is a disaster, and we really should make a kind of a similar functionality that backs up the tree code. Now, I'm thinking that we should just... We've taken all the time to write this, and I don't really want to duplicate too much code. So, the code to back up the tree would just be like a wrapper to the byte backup code, but it would just be a void pointer wrapper, right? So, so we could overload these to be for void pointers, and this is we could just I don't know where we want to put it. I guess if we want to say like backup things that are not pixels, right? So we could say like backup things that are not pixels, and then we could make a section for this, and we could try to back up and restore that other data as well. And because we added so many particular things to those tests, I'm fairly certain that, well, I'm not completely certain that if we screw this up, the test will fail. But yeah, let's try to back up things that are not pixels, right? So when we see that we have like backup here, let's just call it pix backup void, right? So kind of like have that kind of convention of when we have an overload, the overload name goes on the end, right? That's been kind of like how I've been doing it. So backup void, and from here, we just want to pretty much take that the same signature, but we just want to make the signatures void. And yeah, so backup void, and then we want a restore void, right? So backup void and restore void. So backup void and restore void, okay? And let's look at the signature, right? So we made the signatures identical for backup and restore, which is nice because now we only need to copy one of these, right? We can just copy the correct signature and we can just throw it on in there, right? We can just be like, bam, done, bam, done. Well, not done yet, right? Because for these backups, we actually need to rename this to void. And for this, we also need to rename it to void, right? And the next part is we need the defines for I32. So define I32, and then down here we'll undef it. So undef I32. The other thing is, since we're calling that specifically typed function for backing up, we might actually need the UO8, because we're going to have to cast, aren't we? Yeah, we're going to have to cast, so we're going to have to define UO8 as well, because we're going to need that. And then on here we can undef U08. Okay. So it takes void pointers, and all it is a wrapper. All it is an unsafe kind of wrapper for this function right here, right? So that's all it is. That's all we're doing. We're just like taking the safeties off and being like, huh, we know what we're doing, right? So to get this into here, it was originally a void pointer, so we want to say, oh, nope, no, you're not that anymore. You're a U08 pointer. What? Who are you? You're not a void pointer. You're like a U08 pointer now, you know? And then the size of data can just stay that way. It's fine, right? Size of data is good. We can take this backup, right? So these are both backup and backup. We'll paste it right here. And we need this to be restore and restore, right? So restore. And we just keep that the same as well, right? So when we're casting things like this, what we're doing is we're kind of we're nullifying the contract. So when you think of types, you can actually think of types as contracts, right? Like when we say this is a double pointer, saying something is a double pointer basically is a contract saying I can dereference this twice and still end up at a valid memory address, right? That's the contract, right? The contract is saying that we can do this many jumps and still get to something that makes sense, right? And not end up in some random-ass memory location. And thinking of types as contracts can really help your reasoning about the code. So, yeah, I do kind of advise, you know, to think of things like this as think of these as contracts. Now, we've just written these wrappers. We haven't made any timestamps on what we were doing, and so we might want to make a note of what we just did here. And so let's do something like this. Let's do at vid iid 0061, and the time is 2 hours, 40 minutes, and 23 seconds. Sure, 23 seconds. Okay. And it's just a simple wrapper with recast. Right? That's all it is. That's all it is, right? It's just a simple wrapper with a recast. And we can take the same timestamp and we can, you know, paste it down here. I don't know if we need to renumber that. But yeah, so all of this right here, this function here, and this function here, all it is just a simple wrapper with a recast, right? We want to back up and restore data of any type. So the overload for that, we're just going to call the overload void, right? Because we're going to back up, what is the type we're going to back up? We're going to back up the void type. We're going to restore something. What type are we going to restore? We're going to restore a void type, meaning any type. And then, you know, we're just going to cast to U08 and U08 double pointers. So U8 pointer and U8 double pointers. And you might think that is kind of unsafe, but to repeat myself, since I made these video timestamps, no, it's not that unsafe, because we just care about how much data is there and the actual bytes. We don't really care what those bytes represent. So the contract for being an unsigned integer type does not really matter. We don't really care about the exact type when we're looking at these contracts. For the contracts, what we only care about for these contracts is, oh, this thing here can be dereferenced once, and this thing here can be dereferenced twice. That's the only thing we really care about in these contracts. And why I'm saying contract is because when you're thinking about types, sometimes it's easier to reason about the code when you say it's a contract, right? Because that's all a type is. That's all types are. They're just contracts, because at the end of the day, all you have is memory addresses and values in those memory addresses. That's all you have. So by think of things as contracts, it can kind of help you understand what's really going on, right? Because the typing is just a much higher level abstraction, right? So anyways, we have this backup and restore void. Let's see if that compiles correctly, see if we massively screwed up anything, and then we'll try to, like, backup and restore 144. Oh, so once we're done calling the function, right, because we kind of pasted that in there, so we need to make sure that we terminate the statement. I like 2 semicolons because this statement started on one line and ended on another, so I like to use 2 semicolons to denote a statement that began and ended on a different line, right? Or began and ended on separate lines, or whatever you would like to call it. So we're still working, right? So we got that compiling. So the next test right here, the next test is we want to try to take the more specific data, right? We want to try to take this thing that we're backing up here. So this thing we're mallocing right here. We're mallocking and memcopying it. We want to try to, God, this is ugly as hell, right? Like I said, it's going to get dirtier before it gets cleaner. So we want to try something like, you know, AAC 2020, Pixback, and backup, and then void. Okay, and then within here, we want to take the original. So this is the original here. So let's get kind of explicit here, rather than using all these defines. So this is exactly what we'd like to back up. And this is a file scope. This is file scope. And it exists on the stack. It's not a pointer. So if we want to back it up, we need to take its memory address. And then for the next thing, the allocation, where we're going to, like, put that stuff, so this LA thing, we need to take that, and we really don't need the specific type. Actually, adding the specific type actually just makes it harder to call this, because then we have to cast it to avoid double pointer later. But here, let's just take that, and the next thing you want to do is we want the size of what we're backing up, right? So backup void, and the way we got, how did we get the size of that? We just do size of, and then tau dirt, yeah, so that's how we did. So let's do size of, and then this guy right here, right? And then we can kind of, like, I don't know, we could do this, right? I don't know, maybe that's a little bit insane of us to line things up that way, but yeah, sure. So we'll give that a shot. And I'm going to assume it's not going to work because we need a void pointer cast and a void pointer cast. Like, it doesn't just let us... It's weird that, you know, it's complaining about the pointer types, but, you know... Well, I guess it's because we have WAir incompatible pointer types, but we don't have the errors for implicit conversions of, you know, unsigned integer types to integer... or to signed integers. We don't have... Whatever. The compiler is sometimes strict and sometimes not strict enough. I like how strict the compiler is being right now. I'm not complaining about this. It's that, you know, in some other cases, I wish it were stricter, and I need to change the settings, but I have load PNG, so I gotta fix that. Okay, so passing argument to incompatible pointer types and back 001. So... so the scary thing about, so I think it would make more sense to make this, hold on, here's backup void, and here we are, like, mallocking, because we're being idiots, right? We gotta comment this out. Like, if we're gonna use this backup void, we gotta comment this out, right? Same thing with the mem copy. Like, if we're trying to shoehorn this in, we gotta comment out the original backup code. Now, the next thing I'm thinking is, instead of calling this LA, I know that's what we're backing up, but I think it's gonna be a hell of a lot easier if we just do, if we just do a void pointer. But then we kind of lose some information on what we're backing up. Well, let's give that a shot and just see what happens, right? So void, if that's void pointer, I assume that this parameters are going to be okay, but this one's still not going to be okay, I think. So, I don't know how I feel about that. Or it's just gonna roll, or it's gonna let us, huh? All right, fair enough. I mean, that was actually kind of surprising. So what is this backup? That's void, and then this tau dirt any is, it's actually, how the hell? I would have expected one of these. I just would have expected that if this required a certain type, and why did this work? Oh, you know why? You know why? It's because its void pointer is right, because now this is a void pointer, right? Right, because we made this void. Since we made this void, it's now, when we take the address of it, we get a void pointer, so that's the correct type. And even though this is not a void pointer, it's being taken to something that takes a void pointer. So a void pointer actually is a little bit more flexible in terms of how you're allowed to pass it around than a void pointer, for whatever reason. And I have noticed this before. It's not something completely new to me, but it's not something I don't do this too often, what I'm doing here. Okay, so let's go over here and let's try to kind of do the same thing and hope that nothing catastrophic happens. So let's take this, and we already did the restore for this, so we want to do restore the void stuff. So we want to do AAC 2020 Pixback, and we want to restore void. And for restoring void, what are the parameters we need? We need the exact same stuff again. So we can take the exact same stuff again. So where's our restore void or our backup void? So this is backup void. So let's just take everything in backup void, and we can just throw it back into the restore void, right? Okay, so we're just expecting that should just work right out of the box, and then we've done fancy pointer stuff that maybe we shouldn't have done, but we did it, so here we are, right? Okay, so, I mean, because we are messing with pointers and whatnot, I kind of expect that if we screwed it up, we'd see something catastrophically horrible. So I'm thinking that we got it right. I am kind of scared, because it's like, it's not something I do all the time. But, we've done it, so before we kind of clean this up, we want to commit this, just to be like, just because it's good to have a snapshot of, hey, it's working here, and then clean it up. To me, that makes kind of sense, just in case, if we ever second-guess ourselves, I don't know, I just feel like it'd be a good idea to, yeah, I think it'd be a good idea to commit this before we start cleaning it up. So, because it's a good, like, checkpoint. It's a good checkpoint, right? Everything's in a working order, and now it's just dirty, and now the next phase is cleaning up, right? So code working, that's a checkpoint, and now we have this dirty code, so now we have to clean up the code, and then once the code is cleaned up, that's like another checkpoint, right? So when I'm thinking of like git commits, I'm thinking of them kind of as checkpoints. So git status, git add dot, and git commits -am, backup and restore utility functions done. backup and restore utils funcs done. To do cleanup. Cleanup code. Something like that. Okay, so then git push github master. And since this is just a disaster, we're not going to commit this to the kanji coder repo. We're just going to keep this in our private repo, then we'll release the code once we have it in like a better state than this disaster, right? So now that that's out of the way, let's take anything that's commented out and just blast it away. So let's just blast this away. And let's blast this away, right? That's commented out. So anything commented out, we're going to blast it away. So this thing, blast that away. And this stuff here, let's blast that away. Okay. And don't abuse the stack. Well, we're still mallocking, so that's still a valid comment. Okay, so we blasted away some comments. We still expect it to work, but edit a little bit of code, make sure it runs. Edit a little bit of code, make sure it runs. That's kind of the goal here, is make sure that we kind of know what we're doing here. Small incremental changes for the win. Okay, so now we have like all these macros, and I don't think we're gonna be using these macros anywhere now. We're like, all these macros that we kind of used, we kind of shoved in there, we don't need any of them anymore. 512 by 512, this is hard-coded into the backup of Tau Depot, right? We don't need that. Now, this is kind of confusing because we call this a backup 02. It's Tau Depot's pixels, and backup 1 is here. That is kind of confusing, but as far as needing these macros, I don't think we need these macros anymore. I think we're good, right? So we can eliminate kind of all that extra bloat that was in the code. And we should be able to do the same here. Like, I don't see any place we're using these macros, so we can eliminate that bloat over here as well, right? So the idea was we wanted to make this a little bit cleaner here. And I don't know if it mattered that much, because it's still kind of busy. So I don't know. I don't know if maybe that just added more indirection, and maybe that was a bad idea, like what we've done here. Or if it was a good idea. I mean, it was a good programming exercise, if anything else, right? Where we kind of know what we're doing. So pack up, so restore, and, you know, we might want a better name for these backups, right? We see this is called, like, calling this maybe dir any, and then calling this one Tau Depot, right? Might make more sense. So let's actually run this, and then I think we are going to refactor those names. Because I think that back with those numbers, the original reason we just gave them numbers was because then we could just keep the way we backed up and restored it was kind of identical. And now we've added some asymmetry to the code, right? With the way we are kind of backing things up, because we have this backup void, which functions a little bit different than this backup here. And I'm not sure how I feel about the way we've kind of introduced this asymmetry to code that was once kind of very symmetrical, or very analogous, right? These used to be very analogous statements, and now they look very different, and I'm not sure how I feel about that. But anyways, that's the way it is now. So let's call this, I'm going to call this dir any. I'm going to call this dir any. And then this right here, I'm just going to align this over here, right? So the idea is just to make it a little bit more obvious of what's being backed up, right? And so for the restore right here, this restore, instead of calling this back, once again, we're going to call it dir any. And that makes it a little bit more obvious about, like, what is being backed up, right? This dir any thing. And we're going to run that, make sure I didn't make any stupid mistakes. Okay. And then, what else do we want to do? So, instead of calling this back 0, 0, we're just going to call, we're literally going to call it tau depot. Tau depot. And then where we see back 002 like this, anywhere we see back 002, tau depot. Tau depot. Okay. So now that that's there, let's run that, see if that works, and then we're done for this session, right? I just wanted to do a quick little session where we kind of like make some type of backup restore utility where, because it looks like this is going to be a very common theme in our code where we're just like, hey, let's take this data, let's go back it up, and then let's poke and prod it to like do our test, and then let's restore it, right? So this is like a common kind of thing, a theme of what I'll be doing, and therefore it kind of made sense to make this kind of reusable utility code, right? So tau depot dir any, and yeah, do after backup, right? Because this edits the data. But then we don't need to use any force clear. Okay, yeah. So yeah, that's good. And then restore. This is still kind of ugly. Where if we could get this all on, if we could get a, well, no, because we have 3 lines here. We could make this all 1 line. But to make this all 1 line, right? To get rid of 2 lines, we would have to add one. We'd have to add a macro here, and so we would end up with the same amount of lines, right? And maybe an extra because we would want some padding for this restore. However, even though it's these more lines, it could be kind of more streamlined in terms of reading it, right? So maybe we should do that. Maybe that would make sense. So if we did like a define and then dir any, like that, since that's what we named this variable, right? And then undef dir any over here. Yeah, I think that could actually really help, because then over here we could just do dir any like this, and dir any over here like that, right? And then with it like that, I believe we would have enough room where we can just do like a, you know, actually I don't know. I don't know if that's, I don't know if that is helpful. I do not know if that makes things better or if that just makes things worse. Right, because we have dir any. Now obviously you can click this and we can see it match everywhere. I don't know how I feel about that. I feel like that actually kind of makes things a little bit worse. I mean, well, here's what I think. I think that shortening it, I think that's a good idea. But putting it on the same line, trying to cram it all there, I don't know if I'm getting any extra benefit. Because what I can do here is, you know, file scope data. Backup data. This is backup copy. Number of bytes, right? So that's kind of what we got going on there. And I think that this kind of thing here, like this formatting looks a little bit better. And we have room to write some commentary on what that is. And obviously we've explained it in multiple places, but you never know where they're gonna look, where someone's gonna look first when they're reading the code for the first time. So having it, you know, there like that could be helpful. So this dir any and whatnot, I kind of like it like that. Tau depot, I don't think we need to, for this we don't even need to do any macro nonsense. So over here, I'm saying, you know, this is a little bit verbose, right? So I'm saying we can be like, bam, and we're still using up just as much verbosity, but some of it's commentary, right? So I feel like that's kind of useful. And the only cost to us is just adding a little bit of indirection with this define. And it's not too much indirection because dir any is still named in here, right? We're just effectively trying to take off namespaces when we do that. And then undef, and we'll do space dir any. Okay. And now we can kind of see all that light up, right? We can see all that light up, and then if we want to see where Tau Depot is being used, we can see that as well. So I think that looks pretty good to me. It is still kind of clunky, right? There's still a lot of clunk here before we get to the main unit test, but I think it's better. I think it's better than it was before. Maybe I'm just biased because I just put a whole bunch of work into it, so I really want to feel like I've made it better or not worse. Maybe once I have more viewers, people can kind of vote on that and say, did I make the code better or did I make it worse today? Okay, so I'm good with that. I mean, it's still working. So, now to test this, like, what if we actually wanted to test this, right? To make sure that the backup and restore was working properly, right? Right, because a lot of things are relying on this. Should we not have some type of unit test for that? And I think we probably should. So what we should do is we should say, you know, AAC 2020 Pixback and unit test, and we'll do a extern U32, and then this guy right here is going to take a U32 as well. And then we'll call it right away. So the idea is that we're just saying the unit. This is the extern there is just to say that the unit test is below us, and we always put the extern right beneath the function we're forward declaring, just so that there's no ambiguity. Whenever we see a function name, we should always know exactly where that function is, right? So if we see the function and there's not a forward declaration immediately above it, then that function should exist below. If there is a forward declaration above it, then that function should exist above. We have this U32, so we don't need to redeclare that because it's already a define. Let's go take this and go create a unit test function. So we'll go all the way to the bottom, right? The unit test you want to keep at the very bottom, and that's because unit tests can get kind of large. They can get kind of large, so we just want to make sure that we don't make any mistake, right? So I think that a good thing to test with this unit test is I actually have some code already that I could do a unit test with this. So I'm going to take that code and run a unit test on it. And there's actually yeah, so let's take this piece of code. Well, it doesn't want to be that. So this stuff here. So I have some bytes that I can actually test this on. So unit test, and it takes a U32 called U32, and then okay. So I got some stuff that I can try to back up, and we'll say that this is and also the reason for this is like if the endianness, if there's some weird like endianness thing that happens with the void pointer cast, and somehow that wrecks things, we're gonna see that. We're gonna see that in here possibly, right? We're gonna see things get flipped around. We're gonna see like the individual bytes possibly get flipped. And so having it like this, like packing it into an array. So yeah, we'll see what happens. So let's do Do we want to call it stuff, or we want to call it, let's call it, backup test data. And let's actually call this, instead of int, let's call it i32. And define i32, define u32. Okay, cool. So then here we're going to do like an undef u32, and then undef i32. Or we did that in the wrong order. We want to undefine it in the for simplicity, make it so that we can kind of like, when we're undefining it, we can kind of like copy paste like that. Is that first in, first out, or is that last in, last out? Or is last in, last out, and first in, first out just the same way to say the same thing? Well, let's think about it. The first in is i32, and then we're undefing the first one out is also i32. So yeah, so it's FIFO, first in, first out. And that's just so that we can maintain the ordering, right? For simplicity. Okay, so now that we have this, like, backup test data, right? It's not much data. We don't really have to, right? If it works with a few data points, it's going to work with, you know, thousands of data points. We don't need a whole bunch of data. And this, we're just going to test out the void version, right? Because we really... Right, because the void version goes to the generic version, and these other specific versions kind of like go to the generic version as well. Now, that does mean that if we made a mistake in how we wrap the functions, that we could screw things up. But I don't know. Do I really want to make things that inefficient? Do I really want to test that big of a block of data? I don't know. We'll think about it. Let's at least put in one test just as a sanity check. Like, I'm pretty sure it all works, because we just took code logic that we already wrote and just kind of like made it into like a reusable kind of thing here. But let's take the backup stuff and let's do it. So let's take this and do you want this at the top of the file? Now let's just keep it here. Let's just keep it here. That is just going to add more clutter, right? The idea is to keep all the unit stuff, test stuff, like down here where we can forget about it and never have to look at it ever again. So the backup test data. Let's so this is our non-freeable stuff. And this is on the stack. This is on the stack. Okay, yeah. So it is non-freeable. So we're treating this as a file scope array, right? We're treating this as if it were a file scope array of some type of data. And then our backup, we're going to say that backup actually, you know what? I don't know. I don't know. Maybe I shouldn't be so OCD. Just put it in there. Backup data. Backup data is just going to be void pointer. Backup data equals void pointer 0, right? Okay. And if we don't set this to void, I believe that will cause problems for us. I think. So the other thing is we got to remove the types here, right? Because we're actually calling it now. Backup test data. We need a pointer, so we'll take that array, and the array technically is already a pointer, but to make it easier to understand, I always like to do this, just because that makes it easier to understand. I didn't realize, this looked really odd to me the first time I saw people do this in some like OpenCL code, but now that I've worked with pointers a little bit more, I kind of see this and I'm like, yeah, this definitely makes it easier to understand. So that's why we do that. So for the backup data, we have a void pointer, but we want a double void pointer. Because we're going to, it's like passing a reference, right? Reference, ref to PTR. So we're going to make another thing called ref to PTR because we were running out of room. And then the thing where we say reference to pointer, we're going to like double label this, right? So ref to PTR like that. And then over here, we're going to do the same thing. We're just going to go paste, bam, and reference to pointer at ref to pointer, right? They mean the same thing. One's just a shorthand version. So, size of data. What's the size of data? Well, it's the size of whatever this is. So, I mean, this is... Let's just use the size of operator. I mean, I guess what we could do is 8 times 4, because it's 4 bytes per... Yeah, let's just do 8 times 4, right? Let's keep it kind of simple, right? So 8 times 4. Okay. Because it's measured in bytes, right? And each one of these are 4 bytes, right? This is 32 bits, 4 bytes, so each one of these is 4 bytes, and there's 8 of them. 8 times 4, right? So, if we've done that all properly, and I'm kind of OCD here, so I see that we kind of have this lined up here, so might as well kind of like be kind of consistent there, even though this kind of looks lopsided now. I don't know how I feel about it, but there we go. That's the way it is. Now that we have the data backed up and restored, before we run the backup, oh, actually, before we run the restore, we haven't ran the restore yet. So what we're going to do now is we're going to do, like, for I32, dex equals 0, dex is less than or equal to, technically, less than or equal to, I guess we'll do 8 times 4. 8 times 4 minus 1. That's a little bit convoluted, isn't it? And then dex plus plus. Yeah, I'm not sure how I feel about that. I feel like maybe I'm being a little bit too convoluted with that. But I like to write inclusive loops. I don't know what to tell you. And also, we didn't write that correctly because we have... Each one of these is in chunks. Actually, no, it is in chunks like this, but we can... So weird things could happen with the endianness if we try to go through, oh no, it's only gonna have, only weird things are only gonna happen if we try to go through each, int 32 in array access it, we're gonna end up with trouble, I think. But if we, because we're gonna end up, yeah, okay, so, well, we'll see. And weird endianness stuff might bite us in the butt with this, but that's kind of why we're writing tests, right? Because we want to see what the implications of what kind of bad things can happen from what we've been doing with messing with segments of memory. Okay, so backup test data needs to be... We need to convert it to a U08 pointer. So we're going to take a U08 pointer, backup test data. And we're going to take backup test data. We're going to do this. We're going to do and. Oh boy, this is gonna get really weird really quick. We're going to do and backup test data 0. We're going to cast it to a U08 pointer, right? So right now it's an I32 pointer, but we're going to take that first slot and the memory address of wherever that is, the beginning, and we're going to cast it to U08 pointer. And then we're going to use an index accessor on it. And that's getting very large, so we know we want to eventually look at these bytes, and we really don't care what the bytes are. But we could just pretend that they're unsigned. I think unsigned would be the best. So let's define U08. Okay, and then over here we're going to do undef U08, right? So undef U08. Okay, cool. So U08 and backup test data, and we're going to try to get in there, right? So let's make... let's just have like a U08 V1 and then U08 V2 for value 1 and value 2, or variable value 1 slash var 1, whatever, it doesn't really matter. Okay. And let's just make a note of where we kind of are here, right? So at vid integer ID and 0061, and really every time I make a new function, I should probably start labeling these, right? And the time is 3 hours, 19 minutes, and 8 seconds. Okay. And right now we are confirm memory copied correctly. Right, that's what we're doing right now. We're just gonna confirm the memory was copied correctly by looping through every single byte. Right, so we're gonna we're gonna pretend that this backup test data here, that is a whole bunch of int32s. We're gonna pretend that it's an array of just unsigned bytes, and we're gonna go through it, right, to get that the value 1, right? And then we're going to do the same thing with the other data, right? So we have value 1, but where is our other data? Our other data is just this void pointer, so it's like this void data, so we can cast it to whatever we want. This looks kind of like some tricky black magic, so U08 pointer. And I don't even know what we're going to do here. Hold on. So it's already a pointer to data. So therefore, we don't need to do this and whatever the heck. We just need to do a cast, right? So U08 pointer and then backup data. Backup data. Okay. And then if we want to keep everything nice and aligned, we can do this like dex. Okay. So if V1 is not equal to V2, then we're going to err and say err copy in unit test failed, right? So the copy failed, right? That's what failed. Okay, and what else? I think that we need a log function for this, and we don't have this in the silence, so we need to add this to our silence object. So let's do a log and say that, you know, it has been entered, right? Well, I just want to make that sure that that we began the unit. We want to know when we began the unit test and when we ended the unit test, right? So right here when we began, and then down here when we ended, just to make sure that it's actually running, right? Because if we write all this code and we're like, oh man, it passes, nothing went wrong. What if it just was because we never ran the code? Or, you know, alternatively, we could just, you know, add a failing condition, right? We could add a failing condition, so maybe we don't need this, right? Maybe I don't want to write that code. Yeah, maybe we'll save that later, right? For what is it? The most efficient code is the code you don't write, something like that. Yeah, let's say that if this passes and we never get a failure, that we'll just like flip this to equal instead of a not equal and see if we can trigger the error to make absolutely sure that the code is running, right? So we have this backup, that's fine. And now the thing here is backup actually creates an allocation. So if we accidentally back something up and we never restore it, we're going to get a memory leak. And that might be important, an important consideration, right? If wherever you see a backup, now you have to see a restore. Otherwise, your memory leaking. Now, because we kept the same signatures for everything, that's kind of nice because now we can just do this and then bam, right? So the whole point of being able to back up and restore is that we want to be able to see that the values kind of match, right? So so the idea is that the data should match here. We should be able to muck with the thing that we backed up, and then we should be able to restore it and then see that it still matches, right? So in here, let's say this, and I'm going to I'm going to take this data, and I'm going to say I'm going to take this data and say muck up the original data. No, let's just mess it up. I'm going to call this mess it up, and this is what I'm going to do to change the data. And what we're going to do is we're going to take all these bytes and we're going to flip them. Okay, so we're going to take all of these bytes that we have here, and we're going to flip the order. And that's going to give us completely different values. And we're going to use those values to, like, override and then check to see if they're appropriately backed up. So we're going to, like, make some space here. We're going to make some space here. And then we're going to kind of, like, waterfall these bytes back down, right? So to flip it around, we're going to take this and then kind of paste it here, right? And then we're going to come over here. We're going to take this. And we're going to paste it over here, right, like that. And we're going to take this, and we're going to paste it over here like that. And then we're going to take this, and, well, it's already on the end now, right? Bam. Okay. So this is the same, right, because it's 0A, 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 so that's fine. But not all of them match. So I guess it's important just to remember that, you know, even if we mess up this data, we're just expecting not all of it to match, but some of it might be the same. So let's take this and paste this here. Let's take this and paste it here. And let's take this and paste it here. Take this and paste it here. Okay. So do we have any matches up there? No, so it's only one thing that matches. Anyway, so okay, so here's our mess it up data. And right here, we check to make sure that the backup data, the test data, and the backup data are the same, right? Because we backed it up. And this actually needs to be restore, right? And then over here, after the restore, we're going to expect to run it again. And if we're restored with the backup data, then once again, the backup data and the the test data that we're restoring, they should match again, right? So you know, at vid iid 0061 and time is 3 hours, 26 minutes, and 59 seconds. Okay, so 59 seconds. And we're just going to say that, once again, the original data should match the backup data, since we just restored using the backup, right? So that is the comment for like what is going on there, right? So okay, so now that we have this, let's V1 and V2, we can still use V1 and V2. We can still kind of access it exactly the same. So let's do this as in, this is restore. This is the restore section, and this is the backup. Right, so both of them are basically the same problem, but one is for the backup and one's for the restore. So here's our restore, and so in the middle here, mess up the original data. Right, so we want to mess up the original data here. And then we want to see if that backup and restore behaves properly, right? Does it actually restore that data or not? So even though we're taking data that is like this data is, you know, int 32s, right? It's int 32s, and they're not individual bytes. In fact, they're individual clusters of 4 bytes. And so what we want to do is we want to make sure that the logic here, this pixel backup stuff, that it's originally designed to just work with byte arrays, but we're making the assumption that, yeah, it's just to work with byte arrays, but really we could back up anything with it if we mess around with void pointers, right? That was kind of the big assumption we were making. And we want to make absolutely sure that we're not wrong about that, because if we are wrong about that assumption, we are going to be in a world of pain. Later we're going to be in a world of pain. A world of, I don't know what the hell is wrong with my code, and I can't find the problem anywhere, and it's just going to be very bad. We, do not want this problem. So, we want to make sure that when we mess up this data, we just want to mess it up, and we're going to use this mess it up data. And so let's do, and we're messing up the original, yeah. We're messing up the original, yeah. So to mess up the original, we're just gonna say for and I32 mess it up and equals 0, and then mess it up is less than or equal to 8 minus 1, right? Because there's 8 of those. There's 8 of them, right? Let's see if that's correct. Okay, so MIT is mess it up. Okay, so we have this mess it up index, right? Because we got 8 values here. We're going to take this the mess it up array here and the backup test data. So we're just going to say that you know, backup test data. The MIT index equals the mess it up thingy MIT, right? That's all we're going to do, right? We're just going to take the backup test, and we're just going to throw in the thing that's supposed to mess it up. And then we want to make sure that when we do this, we're going to say, UO8 sum don't match equals 0, and then we're gonna say in here, we're gonna say before we do the assignment, we want to do v1 equals this MIT, and then v2 equals this right here, right? And we just want to make a quick comparison to make sure that in fact sum don't match, right? So if v1 not equal to v2, sum don't match. I can just do a plus plus to see how many of them don't match, right? Okay, sum don't match. Okay, v1, v2, and then we're gonna assert that sum don't match is greater than or equal to 1, right? We need at least one thing that doesn't match. And we can make a note of why this is. So, at vid iid 0061, and the time being 3 hours, 32 minutes, and 32 seconds. And we're going to say, you know, if all new values match, then we really haven't messed up anything, and we can't see the visible effects of restoration, right? I don't know if that's the best commentary, right? But the idea is that, you know, if the data doesn't actually get changed because all those values were the same miraculously somehow, with our mess it up, then we don't actually see the effects of restoration. So at least one of these things that we're assigning here needs to be different, right? So V1 and V2, these are the two values that we're working with to mess up the data. If V1 is not equal to V2 in one of these iterations, some don't match, plus plus, to see that there's at least one of these values that's going to get assigned that does not match. And then they're going to take the original backup test data, so this backup test data, and we're going to muck it up with this mess it up variable, right? So mess up the original data, and then we're going to restore that data, and then check it, right? We're going to check to see that it all matches. So let's see if we can actually kind of like see if we can indent this and then name this as restore and check, maybe. And we kind of have enough room. Let's just rename this in bytes. Or how about units? Units are bytes. How about units, bytes? How about that? How about that? Yeah? And this is cutting it close, but it's right on the border. So we're just going to call this restore and verify. Verify? Yeah, restore and verify. And then over here, down here, we're going to call this something. I don't know what we're going to call this. Well, what am I talking about? It's the same exact label. Okay, restore and verify. Cool. So, on the top here, we want to keep something similar, right? This area right here. We had restore and verify, so this is backup and verify, right? That's what this is? Yeah, okay, get this backup and verify. So let's indent this right here. Do we want to... Does that belong... Actually, no, this is variable declaration, so let's take this and put this over here. And we'll make a variable declaration section as well. Variable, this is actually like variable and data declaration. I say data declaration because this stuff is kind of like, I don't know, maybe I'm just making up stuff, but I don't know, it feels like a nice label, so we'll go with it, right? Actually, data declaration isn't quite right. It's variable and data. I don't know. So you declare and assign, I guess. So really it's and data assignments. That kind of reads really weird, but I guess that is the proper label. And then over here, we'll just say units are bytes. Units, bytes. And now in here, we can say that, right, we have the restore and verify. This is backup and verify. All right. So backup and verify. And then over here is backup and verify as well. So let's take this. Backup and verify. Cool. Okay, and let's move this semicolon over here. So it's right on that border, but it's still within the range of where it needs to be. Okay. So that looks like it's... I think we're ready to go. I'm kind of nervous, but let's roll. Let's roll this unit test and see if we're complete idiots or not, I guess, right? Okay, yeah, let's roll it. Let's roll it, see if this test works, and if it doesn't work, then I don't know. We'll figure it out, right? Too few arguments, so that's just me not knowing how to call a function, I guess. Okay. If we say it takes a U32, then we gotta call it with the U32. Conflicting types. Oh, hold on. It's, wait, no. Does this unit test not take a... Oh, it's this. Got it. And we don't return. We need to return, don't we? So we're not really going to return anything useful. We're just going to return, you know, a 0. And then, you know, maybe in the future we'll have some type of thing we'll do with that. But it doesn't seem like it. It seems that we're just doing this because... it seems right now that we're kind of just doing this because... we've been doing it for all the other codes. We just have to be consistent. So define, and then air, and then we'll do like AAC 2020 pixel backup and halt. Right, we use the word halt for our air functions. And then down here, we're just going to undef that. Okay. So let's take a look at that, see if that works. And unused parameter. Oh yeah, because right, we did all this crap where we include U32s that we don't use, and then we have to pay for it, and we have to write no ops all over the place. Reserved for future use, right? There we go. So now, are we in good standing? Are we in good standing? Oh, something's happened. Okay, so, Ooh, that's really bad. That's bad. That is, that's bad. Okay. So, something was wrong with one of our assumptions, that's for sure. And because, yeah, we seg-faulted somewhere in here, so we did bad. We did very bad. Okay, so... Well, let's think about what's going on here. MIT less than or equal to... well, what's this? Why do we have an 8 times 4? Why the hell do we have an 8 times 4? Yeah, this is a number of bytes. 8 minus 1. So we're trying to cast it to this. That's fine. Cast it before we access it. So it feels like the 8 times 4 is actually correct. 8 times 4 minus 1. And it feels like this one is actually wrong. But we're seg-faulting. Oh no. Wait, hold on. Backup test data. 8 bytes, right? Yeah, 8. So, the backup test data, MIT comparing, MIT this equals MIT that, whatever. That looks correct. So it's probably this that's not right. I thought we could get away with that, though. I thought we could kind of... So we take the backup data. What's the backup data? Backup data is this weird-ass void pointer. And we're going to change it to a U8 pointer, and then we're going to try to index into it. I'm going to guess that's what's giving us the problem. Well, I'm glad we gave it some tests here, because I don't know what's going on. We're doing something really stupid, because, you know, we're slinging around void pointers here and, like, recasting things. But the basic essence of the problem is, right, we're trying to take this array of int32s and treat it as a byte array, and then test that, you know, we can... back up and restore the memory, right? So we wrote some utilities to back up and restore memory, and it uses like a mem copy and a malloc behind the scenes. And there's probably something about our understanding of how memory is interpreted that we have completely wrong. And since we're just kind of like being all willy-nilly and slinging around, yeah, because we're saying 8 times 4 because we're seeing these eight values here, but they're all int 32s. So we're thinking that, oh yeah, that would be this many bytes, right? If we're going to treat that data as just an array of bytes, but it's not quite working. So what we might want to do is we might want to try a simpler test, right? We might want to try a simpler test without, actually what we might want to do is we might want to try these same arrays of data, but we might want to break apart each one of these individual bytes and give them a shot, right? And see what happens if we use just a byte array. But before we do that, we probably should do like a little log here, because somewhere we're segfaulting. So let's just kind of log here and make a note of, you know, here's the point at which we entered the unit test, here's the point at which we exited, and then make some logs in between. So begin, and then we're going to need a 0 for a null pointer, because it takes extra info if it can get it. And then down here, before we return, we're just make a note that we exited the unit test, and then somewhere in between this, there is some type of segfault happening. Or at least that's, you know, it had been a few months since the last segfault, and now we just hit one. And that's because I wasn't doing weird stuff with pointers recently, but now I am. So we need a log function, so we'll just say log function is typically second, and see if that works. Nope. So let's just take that and put that in our notes, because we'll make that a shortcut later. How about, what if I just type typically second? Typically second. Nope, that isn't a shortcut either. I mean, I've written this plenty of times, so it's like I can just cut it and paste it from somewhere else, but I would like to, how about generic log function? Do I have like a shortcut called that maybe? Nope. How about just generic log? Do I have something that's just generic log? How about I swear I have a shortcut for this. Generic log. Yeah, info any paste, right? Yeah. So let me just take a note of that so that I have it for next time. Info any paste, and today's date is 12/26. So all right, 12/26. So it's 10 days since I used this shortcut last. Okay, so info any paste. Let's use that. So info and any, and then underscore paste. And great, it is a shortcut, but we were stupid and we didn't make it paste the file contents. So now we gotta go and find it and edit that. So hold on. Paste file. So yeah, so now we're just screwed with that. We gotta actually go and find it in, so it's in our shortcut files, AA2, AAC 2020, snip, log after halt. So it's like, let's just go in there and find it and reuse it. And then the next time we'll have it accessible in our shortcuts, but right now we did not wire those up correctly. So AutoHotkey, shortcuts, and then it's in our snips, or no, it's in SC files, then snips, and then it's in AA2, or hold on, AutoHotkey. Where are we? Are we not in the correct place? No, we should be in the correct place. Oh, not snip. Snip is the second thing. So first it's AA2, and then it's snip specifically for AA2. So, and this is why I have shortcuts for this kind of stuff, because like if you keep these snippets in like folders, like it takes a while to navigate this, and if you have it just at your fingertips, it's kind of nicer, right? So okay, we have this log after halt, and we'll just paste this down here, and then we'll just kind of find and replace everything, right? So we'll take the system name right here, And we'll just call this Pixback, right? And then over here, we'll do silence.pixback, all capitals, just because I know that's how that needs to work. And then right here, we'll do, it looks like we just want a Pixback log. I believe the reason we just call it Pixback log is because I figure if I see this log message, I don't really care about the namespace. But now that I think of it, well, that kind of makes sense until somebody else is using our library code, and then they might need to see the library namespace on that log message. I'll think about the design decision later, I guess. So silence.pixback. So we actually need to go into our silence object and add the Pixback sublibrary to it. So if you go into silence and go into the data, we have like a big list of all the different library systems that we can silence. So we want to find, let's see, Pixback silence. Where are we going here? Pixback is going to be right after the Pix name, right? We decided that Pixback was right after Pix name. So we're going to do like a U08 and Pixback, like that. And then we'll say, we'll add an X because we're actually adding the silencing code right now. Okay, and then remember, after Pix name, so we should be able to find it after here. So we'll go over here, and in Pixback, we'll go dot Pixback, and then we'll do on. Okay, cool. So Pixback and on. Okay, cool. So now that that's in place, we're gonna expect to like see some type of logging message that gives us at least information that we have entered the test where we think we've entered it, right? And let's just give that a shot. Also, we need to make sure that we create the log macro correctly. So all the way down here where we're doing our unit test code, where are we in our unit test? So in our unit test, we need to define log and info any, right? Okay, so now that we have this log, we gotta undefine it down here. So undef and then log. And let's give that a shot, right? And I'm expecting to see at least one message, but then I'm expecting bad things to happen. Yeah, so we began the unit test, and then something catastrophic happened in that unit test. So the question is, well, what did we do wrong? And we could have done a lot of wrong things. So what we can do here is we'll create log messages for each one of these sections, right? So log, and we'll call this one, you know, backup and verify. And 0, right? And we might want to say, you know, AAC 2020. No, we don't need to do that because the log message will kind of cover that. We can just call it Pixback. Pixback, backup, and verify, right? And we can say, yeah, sure. Let's just put it there. Let's not get too crazy here. And then mess up original data, right? So we could say, we could go right here and log this, and I see that we kind of screwed up our indentation here. So mess up the original data, okay? And then here we kind of have to change our sentences here a little bit. Move that over. And then we can kind of take all this and just go bam, bam, bam. Okay. So log that. And then we need a log for whatever this section is, right? And the log for this section is restore and verify. So restore and verify. And so we're going to hope that, I don't know what we're really hoping for to find yet. So, you know, we're hoping that we can isolate what's happening, and we're hoping it's just something stupid and not some fundamental misunderstanding about how the code needs to work. So let's see. We have back up the original data, and then restore and verify is actually where we're having problems. I actually thought it was going to happen a lot earlier. So restore and verify, we have these bytes and backup data. backup test data 0. So the backup test data 0 is kind of like where we're trying to like put this back. The backup data, I thought that was correct. So I am kind of shocked here. So since we know it's kind of failing in restore and verify, let's label this like 001. And then once we call this next function here, right? Because we're thinking that it's probably the restore function that's doing it, but we don't know for sure. So we're gonna do like this right here. And then if we get to the end of this section, we're just gonna call this 3, right? And this is just so we can kind of nail down a little bit better where that is happening, right? And hopefully it's, I'd like it be in this loop, because if it isn't this loop, it'll be a lot simpler to nail down. If it's happening in the restore, then we're kind of just in trouble, aren't we? So that's nice. So 1 and 2, we got that happening. So here's 1, here's where that restore is happening, and then the number 2. So when we're going through these indices, we're doing this incorrectly. So let's take a look at that. So they got like 8 times 4 and minus 1, so that's why I was expecting the index to be correct. And this is our backup test data. This is our backup. Oh, yeah, that's right. So now this is working as intended. So backup data is just backup data. Where are you, backup data? Backup data. We made it. We made the backup data, right? The functionality of that is that after we restore, it nullifies the pointer, and that's by design. So we're gonna take backup data copy. We're gonna just make a duplicate copy of backup data to test with, right? And this needs to match this exactly, right? And then what we're gonna do is instead of take it like this, we're gonna say like, we're just gonna say assert, and then we're gonna say void pointer 0 equals backup data, right? So when we restore the data, it dumped everything out of here. It put it in here, and then it nullified that pointer so that it wouldn't accidentally be reused, right? And then we accidentally reused it, and it gave us a seg fault. So it was working as expected. But what we can do is we can just do the backup test data copy, right? So backup test data copy is the same exact stuff because we just copied it and renamed it. And we can use that to kind of make sure that everything was restored properly. And so far, it looks like it's gonna be all right here. But yeah, backup test data copy now. Why are we doing this? Oh, I kind of see. So we gotta do. Let's do it like that. Let's do it the same way. Ooh. That is unfortunate that it is making a lot of extra... takes up too much room for us. So let's do, let's just call it backup test copy. And we'll just say, these 2 arrays must have identical data, right? We'll just say that. We just want to make a note that these 2 arrays must have identical data. Let's not call it these 2. Let's just say 2 arrays must have identical data. Okay, right? So let's just, make another section there, indent that. This array must have some different data. So this array must have some different data. So the reason I'm adding a label for this as well is because I really don't like how this is no longer aligned with this. So in order to make that aligned with that, and also abide by our kind of like our indentation rules. We have to like also label this, right? So that's what that's all about. So okay, so backup test copy. I like that. Let's go with that. And then I swear to God, we had another place with that. Was this the only place we referenced it? Yeah, I guess that's the only place we referenced it. Okay, fine. And then... Alright, yeah, let's give that a shot. Let's give that a shot. I think that we got it. I think we got this. I think we got this. So let's give this a shot and just see kind of if this works or not, right? Yeah, I'm hoping. Alright, cool. So we know the tests were running because of how they were like crashing on us and whatnot, but yeah, we're good. Like, yeah, okay, I'm happy with that. I'm happy with that. We wrote some crazy ass like test code, and it works, right? Even though this data is not actual byte arrays, and our underlying functions are meant to work with byte arrays, it still works, right? Because when we're trying to back up and restore the memory, we really, like I said, we don't care about what the type of that memory is. We just care that, you know, here's how large the memory segment is, you know, malloc it, free it, you know, we're good to go. So, excellent. So that's good. Let's back that up, right? So we might want to make a note here that first draft was finished. So like at vid iid and take the time. So 0061 and the time is 3 hours 59 minutes and 32 seconds. Okay. First draft of unit test finished, right? So just a little documentation of, you know, what happened, right? So we just finished the first draft of the unit test, and it passes. Right? And that is so if someone's kind of like trying to scrub through the code and be like, well, where did they write this unit test code? Then they can find it, because we have a little comment. And we're not being totally good about labeling everything with these little timestamps, but, you know, some timestamps is better than none, right? So, yeah, that's good. Let's rerun it. Just make absolutely sure that it runs. I mean, just a sanity check, right? Because we just added... anytime I touch that code, before I commit it, I absolutely want to make sure that it still runs, right? So, let's do a git bash here. And a git status, and a git add dot, git commit dash am, pixel backup unit test. Okay, git status, git push GitHub master, and then because we're in like a good working state, we'll also push up to the public repo, right? So we'll do a git push and kanji coder. Yeah, and we're going to end the stream, because I only wanted to go for an hour, but I also wanted to get, like, a finite amount of work done, so I said an hour, and we went for 3, so I guess, you know, I don't know what the exact formula is my dad used to say, but, you know, it definitely always takes longer than you think something's going to take, you know. It's ridiculous. Alright, so we're done for today. And I'll see you in the next one.